सर्वांनी पाहुण्यांचं आगमन होत आहे. एका क्षणात पाहुण्यांचं आगमन होत आहे. सर्वांनी मध्ये येऊन समोर बसावं. समोरच्या खुर्च्या रिकाम्या टाकू नका. समोर येऊन बसा सर्वांनी. सर्वांना विनंती आहे मध्ये येऊन बसायचं. सुस्वागतम 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 सुस्वागतम. सर्व मान्यवरांचे राजश्री शाहू महाविद्यालय लातूर तर्फे हार्दिक स्वागत. सर्वांनी टाळ्यांच्या गजरात पाहुण्यांचं स्वागत करायचं आहे.
Welcome, a very pleasant with immense pride and pleasure on behalf of Department of Chemistry and Analytical Chemistry, I extend a warm and hearty dignitaries, eminent scientists, respected resource person, researcher and dear students to this one-day national conference on chemistry frontier in applied science and technology sponsored by PM-USHA.
Chemistry stands at the forefront of applied science, driving breakthroughs in sustainable materials, renewable energy, and advanced technologies like nanomaterial and green synthesis. This conference explores these frontiers, fostering collaboration to address global challenges such as clean energy and environmental sustainability.
Lighting a lamp does not consume oil, it spreads light. To begin this auspicious academic gathering, we shall now proceed with a traditional lighting of the lamp, symbolizing the removal of ignorance and the awakening of knowledge. I respectfully invite our honorable chief guest, guest of honor, principal, head of department, and organizing committee member to kindly come for the lamp lighting ceremony.
तमसो मा ज्योतिर्गमय, असतो मा सद्गमय, मृत्युर्मा अमृतमय. म्हणजे अंधाराकडून प्रकाशाकडे, अज्ञानाकडून ज्ञानाकडे आणि जगात जे मृत्यूचे अखंड तांडव सुरू आहे त्याला थांबवून अमृताची शिक्षा करणारी पिढी नक्कीच विज्ञानातून आणि संशोधनातून निर्माण होईल. थँक यू respected dignitaries. Let this conference be the spark that catalyzes
We felicitate not an individual, but the excellence, dedication and inspiration they represent.
I request our college principal, Dr. Mahadevji Dhwane sir, to felicitate chairperson of this session, Honorable Sri Gopal Shinde sir, Joint Secretary. I request our college principal, Dr. Mahadevji Ghavane sir, to felicitate chairperson of this session, Honorable Sri Gopal Shinde sir. Joint Secretary, Shri Chhatrapati Shikshik Samstha, Latur. Thank you, sir.
I would like to request Honorable Gopal Shinde sir to felicitate today's chief guest, Dr. Prakash Bhatlavkar sir, Professor and Emeritus Scientist, CSIR, NCL, Pune. This felicitation is a small token of our deep gratitude for your remarkable academic journey and service to science. Thank you, sir.
Now, with great respect and gratitude, we felicitate our respected principal sir for his. I invite our principal, Dr. Mahadevji Ghavane sir, to felicitate Dr. Satish Patil sir. I request to our principal, vice principal sir, Shinde sir, to felicitate Dr. Vasawa sir. Now, with great respect and gratitude, we felicitate our respected principal sir for his invaluable leadership. Thank you, all the dignitaries. Now, I invite our respected head of department to deliver introductory address.
Very good morning and warm welcome to one and all to PM-USHA sponsored National Conference on Chemistry Frontiers in Applied Sciences and Technology, Chem-FAST-2025, organized by Department of Chemistry and respected chairperson, Honorable Sri Gopal Shinde sir, Joint Secretary, Shri Chhatrapati Shikshik Samstha, Latur. Moderator of this conference, Professor Prakash Bhatlavkar sir, Polymer Science and Engineering Engineering, and about 150 participants registered from different districts of Maharashtra, different states, Karnataka, Gujarat, Telangana, Rajasthan, Goa, all over India. Once again, I extend heartily welcome to all participants and wish them enjoyable experience at Chem-FAST 2025. Thank you, all esteemed resource persons, management member, principal, vice principal, scientists, researchers, experts, teachers, and student participants to join us. Thank you very much.
Thank you, sir. To mark the beginning of today's academic proceeding, I respectfully invited our esteemed principal to deliver welcome address.
राजश्री शाहू महाविद्यालय या पावर ऑटोनॉमस इंस्टीट्यूट केमिस्ट्री विभाग आयोजित वन डे नॅशनल कॉन्फरन्स ऑन केमिस्ट्री फ्रंटाईल अप्लाइड सायन्स अँड टेक्नॉलॉजी त्याच्या उद्घाटन समारंभाचे अध्यक्ष आमचे मार्गदर्शक आदरणीय गोपाळजी शिंदे सर, या उद्घाटन समारंभाचे उद्घाटन आणि ज्यांचा एक प्रदीर्घ असा या क्षेत्राचा अनुभव आहे आणि महाराष्ट्रातीलच नाही तर देशातील एक नामांकित संस्था म्हणून जी ओळखली जाते त्या NCL मध्ये असलेले प्रोफेसर आदरणीय प्रकाशजी वडगावकर सर, व्यासपीठावर उपस्थित महाविद्यालयाचे प्राचार्य आदरणीय शिंदे सर, ज्यांचं सविस्तर असं मार्गदर्शन आपल्याला या कॉन्फरन्सच्या सेमिनारच्या निमित्तानं होणार आहे. ते गुजरात युनिव्हर्सिटी अहमदाबाद या ठिकाणचे प्रोफेसर आदरणीय दिलीप कुमार वसावा, आपली रिक्वायरमेंट जी असते ऊर्जा त्याच्यामध्ये ते काम करत आहेत आदरणीय सतीशजी पाटील सर, आणि त्यांचा मला सार्थ अभिमान आहे कारण ते या महाविद्यालयाचे अलुमनाय आहे. 1995-96च्या बॅचचे ते या महाविद्यालयातून BSc झालेले आहेत आणि त्यांचं वेगवेगळ्या ठिकाणी MSc असेल, पोस्ट डॉक असेल, रिसर्च असेल, US असेल, जर्मनी असेल, अशा वेगवेगळ्या ठिकाणी जाऊन रिसर्च केलं आहे. आणि म्हणून या विभागाचे कन्व्हेनर आदरणीय पाटील सर, समोर बसलेले मोमीन सर, तायडे सर, सुदेवाड विभागाचे प्राध्यापक, वेगवेगळ्या महाविद्यालयातून आलेले सर्व प्राध्यापक, संशोधक, विद्यार्थी आणि विद्यार्थी मित्रांनो, सगळ्या मान्यवरांचे या 7 कोटीच्या फंडामधून एक रिझर्वेशन असेल, जवळपास 2,71,00,000 रुपये रिझर्वेशनसाठी, 1,96,00,000 रुपये ही इक्विपमेंटसाठी आणि जवळपास 32,00,000 रुपये आणि सॉफ्ट सपोर्टसाठी त्यामध्ये ही पहिल्यांदा PM-USHA महाराष्ट्रामध्ये काम करत असताना राष्ट्रीय उच्चतर शिक्षा अभियान USHA या दोघांनाही आणि त्यांचे जे डायरेक्टर आहेत डॉक्टर राजेंद्र बाळूंचे त्यांना मनापासून खूप खूप ला स्थापन झालेले हे महाविद्यालय केवळ 50 विद्यार्थ्यांना घेऊन हे महाविद्यालयाची सुरुवात झाली आणि आज 55 वर्षाच्या नंतर हे महाविद्यालय जे आहे हे जवळपास 12,000 विद्यार्थी या महाविद्यालयामध्ये आज शिक्षण घेत आहेत. ज्यावेळेस हे महाविद्यालय सुरू झालं तेव्हा तर वी हॅव ओनली 2 UG programs, just B and BCom, and now we have 8 UG programs, 30 PG programs, and 11 research centers recognized by our parent university. संख्या तर वाढली पण संख्येसोबत गुणवत्ता सुद्धा या महाविद्यालयानं जपण्याचं काम मागच्या 55 वर्षांमध्ये. तर आमचं 1980 ला पहिलं मेरिट आलं आणि 1980 ला पहिलं मेरिट आल्याच्या नंतर त्यानंतर बाकी पुढचा जो काही प्रवास आहे आमची स्पर्धा ही दुसऱ्या कुठल्याही इन्स्टिट्यूट सोबत नाही, या महाविद्यालयाची स्पर्धा या महाविद्यालयासोबत. कारण दर वर्षाला या महाविद्यालयाचे जवळपास 800 पेक्षा जास्त विद्यार्थी हे मेडिकल कॉलेज होतात. या मेडिकल कॉलेज सोबत एम्सला जाणाऱ्यांची संख्या सुद्धा दिवसेंदिवस वाढत चाललेली. 50 पेक्षा जास्त विद्यार्थी दरवर्षी एम्सला जातात. IIT सारख्या नामांकित इन्स्टिट्यूट मध्ये 55 पेक्षा जास्त विद्यार्थी दरवर्षी IIT ला जातात, NIT ला विद्यार्थी जातात आणि महाराष्ट्रातल्या सगळ्याच महाविद्यालयामध्ये जे काही महाविद्यालय गव्हर्नमेंट प्रायव्हेट असतील तर शाहू महाविद्यालयाचा विद्यार्थी नाही असं एकही महाविद्यालय मेडिकल कॉलेज आपल्याला सापडणार नाही. म्हणून ज्या पद्धतीनं हे महाविद्यालय डॉक्टर्स आणि इंजिनियर घडवणारं एक खान म्हणून ओळखलं जातं, त्यासोबतच महाविद्यालयामध्ये कॉमर्स फॅकल्टीमध्ये CA फाउंडेशनची आम्ही बॅच घेतो आणि त्याचा रिझल्ट जर आपण पाहिला तर दरवर्षी ऑल इंडिया रँक मध्ये 50च्या आत महाविद्यालयाचे 4-5 विद्यार्थी आणि CA फाउंडेशनचा रिझल्ट लागतो थ्रूआउट इंडियामध्ये 25 ते 30% दरम्यान केलेले असतं, पण महाविद्यालयाचा नेहमीचा रिझल्ट असतो 65 ते 70% मध्ये रिझल्ट असतो. आणि म्हणून लातूर जिल्ह्यातले लातूरमधले डॉक्टर्स, इंजिनियर्स आणि CA एका कार्यक्रमामध्ये मी बोलत असताना म्हटलं की 50% इथे CA हे आमच्या एकट्या महाविद्यालयाचे विद्यार्थी. पण त्यांनी मला म्हटलं की तुमचं चुकतंय, तुम्ही दुरुस्ती करा बळगावमध्ये, आणि सांगितले की या शहरातलेच नव्हे तर अनेक ठिकाणचे पण या शहरात काम करणारे डॉक्टर्स, इंजिनियर्स आणि CA हे 90% पेक्षा जास्त हे राजर्षी शाहू महाविद्यालयाचे विद्यार्थी. म्हणून ज्या पद्धतीनं ज्युनियर विंग मध्ये महाविद्यालय काम करतं अगदी त्याच धर्तीवर वरिष्ठ महाविद्यालयामध्ये सुद्धा हे महाविद्यालय काम करतं. आणि मग 1994 ला सर आमचा रिझल्ट जो येतो जेव्हा आम्ही ऑटोनॉमी मध्ये नव्हतो 2013च्या अगोदर, तेव्हा इथं 1994 ला स्वामी रामानंद तीर्थ मराठा विद्यापीठाची स्थापना झाली आणि त्यांचे रिझल्ट जेव्हा यायचे ग्रॅज्युएशनचे तेव्हा BA आणि BSc चे रिझल्ट हे 50% पेक्षा जास्त विद्यार्थी ग्रीड मध्ये हे एकट्या शाहू महाविद्यालयाचे आणि पहिला, दुसरा, तिसरा महाविद्यालयाचे विद्यार्थी असतात. आणि आमच्या वाणिज्य शाखेचे पहिला, दुसरा आणि तिसरा 1994 ते 2013 सतत 21 वर्ष पहिला, दुसरा आणि तिसरा हा राजर्षी शाहू महाविद्यालयाचा विद्यार्थी आहे. आणि या विद्यार्थ्यांमुळे महाविद्यालयानं संस्थेनं आपण ऑटोनॉमी घेतली पाहिजे, आपण स्वायत्त झालं पाहिजे, म्हणजे आपल्याला वेगवेगळे काही प्रोग्राम सुरू करता येईल आणि आपल्याला चांगली याच्यामध्ये डेव्हलपमेंट करता येईल. या भूमिकेमधून 1913 ला हे महाविद्यालय स्वायत्त झालं आणि 1913 ते 2024 पर्यंत मराठवाड्यात हे एकमेव महाविद्यालय. आता गेल्या वर्षी संभाजीनगरचं देवगिरी कॉलेज एक आता स्वायत्त झालेलं आहे. अजून दुसरं कुठलंही महाविद्यालय हे स्वायत्त झालेलं नाही. आणि या स्वायत्तेमध्ये आम्ही वेगवेगळे उपक्रम राहू, वेगवेगळे प्रोग्राम आम्ही नव्यानं सुरू करतोय. यावर्षी आमच्या अकॅडमिक काउन्सिल गव्हर्निंग बॉडीला मान्यता दिली. नव्यानं आम्ही BBA आणि MBA यावर्षी सुरू केलं आणि AICTE कडे अप्रूव्ड असणारे जे टेक्निकल युनिव्हर्सिटी लोन आहेत त्यांच्या अग्रेशन साठी आता आम्ही गेलोय. त्याच्यामध्ये आम्ही BCA असेल, MCA असेल आणि BTech बायोटेक्नॉलॉजी हे नवीन प्रोग्राम आम्ही या ठिकाणी पुढल्या अकॅडमिक इयर पासून आपण सुरू करतोय. आज वरिष्ठ महाविद्यालयामध्ये शिक्षण घेणारे UG आणि PG ची संख्या जवळपास 5000 आहे आणि आमच्याकडे रिसर्च करणारे जे 11 रिसर्च सेंटर आहेत आणि या 11 रिसर्च सेंटर मध्ये जवळपास 127 पेक्षा जास्त विद्यार्थी महाविद्यालयामध्ये PhDचा प्रोग्राम त्या ठिकाणी करत आहेत. म्हणजे संशोधन असेल, रिसर्च असेल, बाकीच्या इतर गोष्टी असतील हे आणि जवळपास 52 पेक्षा जास्त वेगवेगळे सर्टिफिकेट कोर्सेस महाविद्यालय चालवतात आणि स्वतंत्र प्लेसमेंट्स हे आमच्याकडे आहे. प्लेसमेंट ऑफिस विद्यार्थ्यांना तुम्ही पीजी करण्यासाठी बाहेर जावं, चांगल्या इन्स्टिट्यूट मध्ये जावं म्हणून महाविद्यालय IIT JAM सारखे क्लासेस तिथे घेतो. आणि दरवर्षी मागच्या 3 वर्षापासून दरवर्षी या महाविद्यालयाचे 10-11 विद्यार्थी आता MSc करण्यासाठी, MSc PhD इंटिग्रेटेड कोर्स करण्यासाठी IIT ला जाऊ लागले, NIT ला विद्यार्थी प्रवेश घेऊ लागले. काही विद्यार्थी आमचे IIT बॉम्बेला आहे, काही विद्यार्थ्यांनी आता MSc केमिस्ट्री याच विषयामध्ये IIT हैदराबाद मधून केलेले आहेत. अशा वेगवेगळ्या ठिकाणी विद्यार्थी जाऊ लागले आणि याच्या बाहेर विद्यार्थ्यांनी जावं, वेगवेगळ्या देशामध्ये जावं. काही विद्यार्थी आमचे अमेरिकेमध्ये पीजी करायला गेले, MSc करायला. काही विद्यार्थी साऊथ कोरियामध्ये गेले, काही विद्यार्थी MBA करायला इंग्लंडमध्ये जाऊ लागले. म्हणजे बाहेरच्या देशामध्ये सुद्धा विद्यार्थी जाऊ लागले आणि त्याचा फायदा विद्यार्थ्यांना होऊ लागला. 2 वर्षापूर्वी आमची BSc केली साईली लोकटे, MSc केलं US मधून आणि तिला 59 लाख रुपयाचं पॅकेज या महाविद्यालयाच्या विद्यार्थ्यांना प्राप्त. म्हणजे या सगळ्या गोष्टी ज्या आहेत अकॅडमिक सोबत विद्यार्थी रिसर्चला आधी सर फोकस करतात आणि त्याचाच फायदा म्हणून कोविशिल्ड लस जी आली ती कोविशिल्ड आमचा मायक्रोबायोलॉजीचा असणारा विद्यार्थी BSc इथं गेला, MSc इथं गेला आणि तो सिरम इन्स्टिट्यूट मध्ये लागला आणि ती कोविशिल्ड लस जी तयार झाली त्या रिसर्च टीम मध्ये संतोष नावाचा या महाविद्यालयाचा विद्यार्थी. अशा वेगवेगळ्या ठिकाणी या ठिकाणी शिकलेला आमचा विद्यार्थी आज मायक्रोसॉफ्ट सारख्या नामांकित कंपनीमध्ये जयपट्टी नावाचा विद्यार्थी की जो आज मायक्रोसॉफ्ट कंपनीमध्ये इंजिनियर नाही, आज एक पार्टनर म्हणून काम म्हणजे US मध्ये तो काम करतो. अशा वेगवेगळ्या ठिकाणी हे विद्यार्थी काम करत आहेत आणि आमच्या संस्थेला वाटलं, आदरणीय शिंदे सर या ठिकाणी उपस्थित आहेत की सगळ्या क्षेत्रामध्ये विद्यार्थी की आता डॉक्टर झाले, इंजिनियर झाले, संशोधनामध्ये विद्यार्थी, प्रशासकीय या ठिकाणी विद्यार्थी करावे, इथून डेप्युटी कलेक्टर, DYSP, IAS, IPS विद्यार्थी व्हावे. त्यासाठी सर आम्ही नव्याने एक वेगळी एक बॅच आम्ही सुरू केली BEच्या विद्यार्थ्यांसाठी आणि मला सांगायला आनंद होतो की 2016 मध्ये ती बॅच आम्ही सुरू केली. आता एक बॅच बाहेर पडते आणि अगदी ग्रॅज्युएशन झाल्यानंतर MPSCनं महाराष्ट्र लोकसेवा आयोगानं ज्या PSIच्या परीक्षा घेतल्या त्यामध्ये अनिशा आगरकर नावाची एक विद्यार्थिनी महाराष्ट्रात पहिली आहे. आज त्या बॅचचे अनेक विद्यार्थी नायब तहसीलदार असतील, तलाठी असतील, ग्रामसेवक असतील, IAS आता आधी विद्यार्थी होऊ लागले. आता PM ऑफिस पर्यंत राजर्षी शाहू महाविद्यालयाचे विद्यार्थी, न्यायाधीश म्हणून काम करतात विद्यार्थी, माजी विद्यार्थी. आणि म्हणून अशा सगळ्या क्षेत्रामध्ये महाविद्यालयाचे विद्यार्थी आता काम करू लागले. मी एकदा एक्झाम्पल देतो की मागे आम्ही एकदा तर आम्ही कोल्हापूरला गेलो होतो एका कॉलेजला, आम्हाला बोलवलं होतं टीम आंदोलनासाठी आणि तिथे त्या कोल्हापूरचे SP आणि ऍडिशनल SP दोघेही, SP असणारे अभिनव देशमुख आणि ऍडिशनल SP असणारे तिरुपती काकडे, हे विद्यार्थी हे राजर्षी शाहू महाविद्यालयाचे विद्यार्थी आणि त्यांना आम्हाला त्यांना माहित झालं की शाहू कॉलेजचे प्राचार्य आणि प्राध्यापक इथं आले. मग आम्हाला त्यांनी ऑफिसला वगैरे घेऊन गेले आणि सांगितलं की कोल्हापूरची सुरक्षा करायचं का ते राजर्षी शाहू महाविद्यालयाचे विद्यार्थी. म्हणजे अशा सगळ्या क्षेत्रामध्ये गोव्यामध्ये आता प्रेझेंट साऊथ आणि नॉर्थ गोव्यामध्ये गोव्याला 2च कलेक्टर आणि हे दोन्ही कलेक्टर नवरा बायको आहेत आणि ते दोन्हीही राजर्षी शाहू महाविद्यालयाचे विद्यार्थी. म्हणजे अशा सगळ्या क्षेत्रात केवळ आम्ही अकॅडमिक नाही, अकॅडमिक अचिव्हमेंट आम्ही करतो. जर आमचा मॅथ मधला ग्रेड 2023 मध्ये मॅथ झालं आणि या महाविद्यालयाला जवळपास 3.49 CGPA घेऊन A+ ग्रेड प्राप्त आणि 3.49 CGPA घेऊन प्राप्त करणारं या विद्यापीठातलं हे एकमेव महाविद्यालय. ऑटोनॉमसच्या गाईडलाईन्स वेगळ्या, अफिलिएटेड काही कॉलेजच्या गाईडलाईन्स वेगळ्या, पण तरीही आम्ही 3.49 CGPA घेऊन A+ ग्रेड मिळाला. अजून आम्हाला 2 पॉईंट मिळाले असते तर आम्ही 3+ आणि ऑटोनॉमीचा विचार केला तर महाराष्ट्रामध्ये 2 क्रमांक. अकॅडमिक ऑडिट आम्ही केलं आणि अकॅडमिक ऑडिट मध्ये या महाविद्यालयाला जे मार्क्स प्राप्त झाले ते 99.48% मार्क्स प्राप्त झाले आणि O+ ग्रेड मिळाला. एवढे हायएस्ट 99.48% मार्क्स घेणारं या विद्यापीठाच्या परिषदाचं एकमेव महाविद्यालय. 2 वेळा या विद्यापीठाचा बेस्ट कॉलेज अवॉर्ड या महाविद्यालयाला प्राप्त झाला. महाराष्ट्र गव्हर्नमेंट साठी आता तो ट्रेनिंगला आहे. तो दिल्लीच्या आयडी कॅम्पसाठी तो सिलेक्ट झालेला आहे आणि आता राष्ट्रपतीला 26 जानेवारीला सॅल्यूट देणार आहे एनसीसी विंग. त्यामध्ये एक विद्यार्थी हा राजेश शाहू महाविद्यालयाचा विद्यार्थी. NSS चे 2 विद्यार्थ्यांचे आयडी स्टेट आयडी कॅम्पला आम्ही त्यांची निवड झाली ते तिथं झालं. म्हणजे सगळ्या ठिकाणी स्पोर्ट्स मध्ये तर आमचं संस्थेला आम्हाला फार चांगलं इन्फ्रास्ट्रक्चर दिलं. म्हणजे अद्यावत जिम नाही, एसी जिम आहे महाविद्यालयाच्या पातळीवर. मी मागे बोललो की इथं स्वतंत्र ओपीडी आहे, फुल टाइम 2 डॉक्टर आहे. म्हणजे केवळ कुणाला दाखवण्यासाठी नाही, विद्यार्थ्यांचं आरोग्य नीट राहावं, त्यांच्या आरोग्याच्या तपासण्या व्हाव्या, प्राध्यापकांच्या आरोग्याच्या तपासण्या व्हाव्या म्हणून संस्थेला आम्हाला 2 फुल टाइम डॉक्टर या ठिकाणी दिले. आणि दर 15 दिवसाचा एक शनिवार त्या ठिकाणी जे स्पेशालिस्ट असणारे डॉक्टर आहेत. मागच्या शनिवारी डेंटिस्ट होते आणि आता तिथं आम्ही तिथं जाऊन आलो की आता आय स्पेशालिस्ट असणारे आमचे जे डॉक्टर आहेत स्वामी सर ते आता विद्यार्थ्यांच्या प्राध्यापकांच्या नॉन टीचिंगच्या विद्यार्थ्यांच्या पालकांच्याही वेळेची सगळी तपासणी करण्याचं काम विनामूल्य या महाविद्यालयाचे विद्यार्थीच करत आहेत. ते माझे विद्यार्थी आणि ती सेवा मोफत विद्यार्थ्यांना आमच्या सगळ्यांना देण्याचं काम ते विद्यार्थी करत आहेत. आम्हाला स्पोर्ट्स मध्ये तर आमचं इंटरनॅशनल आहे. आमचे विद्यार्थी मागच्या 4 वर्षामध्ये चायनाला 2दा खेळून आले, भारताचं प्रतिनिधित्व. सॉफ्टबॉल, बेसबॉल, जिम्नॅशियम मध्ये साऊथ कोरियाला खेळून आले, तैवानला खेळून आले, मंगोलियाला आमचे विद्यार्थी खेळून आले. म्हणजे स्पोर्ट्स मध्ये तर आम्ही केवळ नॅशनलवर नाही तर इंटरनॅशनल पातळीवर महाविद्यालयाचे विद्यार्थी या देशाचं प्रतिनिधित्व करतात. अशा सगळ्या ठिकाणी एक अष्टपैलू विद्यार्थी निर्माण करण्याचं काम हे महाविद्यालय करत आहे. वडगावकर सर आमची लायब्ररी, पाटील सर आमचं ग्रंथालय, सर our library open access, 100% open access library. We provide 100% open access. म्हणजे सगळ्या विद्यार्थ्यांना पाहिजे ते पुस्तकं आम्ही विद्यार्थ्यांना देतो. 100% ओपन ऍक्सेस विद्यार्थ्यांना आम्ही देतो. आणि या सगळ्या सुविधा उपलब्ध करून देण्याचं काम आमच्या संस्थेचे जॉईंट सेक्रेटरी आदरणीय शिंदे सर, त्यांची सगळी टीम, आदरणीय डॉक्टर गोपाळजी पाटील सर असतील, आदरणीय अनिरुद्ध जाधव सर असतील, आदरणीय PR देशमुख साहेब असतील, आदरणीय शिंदे सर आहे, त्यांची सगळी टीम आमच्या पाठीशी खंबीरपणे उभी असते. आणि त्याच्यामुळे आम्ही हे सगळं करू शकतो. विद्यार्थी वेगवेगळ्या ठिकाणी रिसर्च मध्ये, आविष्कारामध्ये, आता विद्यापीठाच्या पातळीवर जे काही आता विद्यापीठाची झाली त्यामध्ये आमचे स्टेट लेवलला 5 विद्यार्थी हे आम्ही हे झाले, सिलेक्ट झालेले. आविष्कार रिसर्च मध्ये अतिशय चांगल्या पद्धतीनं काम महाविद्यालयाचे विद्यार्थी करतात. या विद्यार्थ्यांना प्रोत्साहन म्हणून महाविद्यालय जो काही त्याचा खर्च येईल रिसर्च करण्यासाठीचा सगळा खर्च आम्ही प्रोव्हाइड. पाटील सर तुम्ही असताना सीड मनी वगैरे नव्हतं. आता आम्ही प्राध्यापकांना वडगावकर सर आम्ही 2-2 लाख रुपये संस्था आम्हाला प्राध्यापकांनी रिसर्च करावं म्हणून सीड मनी आम्ही प्रोव्हाइड करतो. आणि आता जवळ अंडर सीड मनी जवळपास आमचे 10-11 प्राध्यापक रिसर्च करतात. म्हणजे रिसर्च वाढावं. पेटेंट आमच्याकडे काही आहे, जवळपास 10-12 पेटेंट, काही त्याच्या डिझाईन असतील, काही पेटेंट असतील, काही ग्रँट झाली महाविद्यालयाच्या आमच्या प्राध्यापकांनी. महाविद्यालयाचा HND सगळं पाहिल्यानंतर एक चांगल्या पद्धतीचं रिसर्च मध्ये सुद्धा हे महाविद्यालयाचे चांगल्या पद्धतीनं काम करतात. आणि बरोबर की त्यातलाच एक भाग म्हणजे एक कॉन्फरन्स, सेमिनार या ठिकाणी आयोजित केलेला आहे. हा सेमिनार या ठिकाणी आयोजित केला आहे. मला वाटतं की हे तिन्ही रिसोर्स पर्सन असते जे आहे ते त्यांच्या क्षेत्रातले एक दिग्गज आहेत. त्यांच्या ज्ञानाचा जास्तीत जास्त फायदा आपण करून घ्यावा. दिवसभर चालणारा हा सेमिनार जो आहे त्याचा जास्तीत जास्त फायदा आपण आपल्या ज्ञानामध्ये करून घ्यावा. पुढे आपण विद्यार्थ्यांनी काय वाटचाल केली पाहिजे, कुठं केली पाहिजे. केमिस्ट्री सारख्या विषयामध्ये फार मोठी संधी आहे. जसं सर सुधारमध्ये काम करतायत. बाकी डॉक्टर APJ अब्दुल कलाम म्हणले होते की ज्याला नोबेल पुरस्कार प्राप्त करायचा आहे त्याला ऊर्जेमध्ये काम करावं, कारण सगळ्या जगाला गरज ही ऊर्जेची गरज आहे. आणि म्हणून पाटील सर आपण अशा क्षेत्रामध्ये आपण काम करताय. नॅनो टेक्नॉलॉजी सारख्या विषयामध्ये डॉक्टर सर काम करतायत. वेगवेगळ्या ठिकाणी आपण काम करताय. तुमच्या ज्ञानाचा, सरांच्या ज्ञानाचा आपण जास्तीत जास्त फायदा करून घ्यावा. त्यासाठी दिवसभर चालणाऱ्या या कॉन्फरन्सला मी खूप खूप शुभेच्छा देतो. धन्यवाद.
50 विद्यार्थी ते 12,000 विद्यार्थी हा महाविद्यालयाचा आलेख आणखी नक्कीच उंचावत जाईल. आपल्या महाविद्यालयातील विद्यार्थ्यांनी संपूर्ण जग व्यापून टाकलेलं आहे. अगदी कमी शब्दात अतिशय महत्वपूर्ण माहिती सरांनी इथे दिली, त्याबद्दल एवढंच म्हणतो. छेदण्या निशाण 3 वेळे पाहिजे, भेदण्या कट्टर पाषाण 2 वेळे पाहिजे, शक्य आहे काहीही, फक्त ध्येय वेळे पाहिजे, फक्त ध्येय वेळे पाहिजे. I respect all the dignitaries to please step forward to publish front page of the book.
केले फोटो घ्यायचा का?
Thank you, sir. Now I request Dr. Kalimuddin Momin sir to introduce our chief guest.
Good morning, everyone. Respected all persons on the dais and organized. One day national conference organized by our department, and here I have given the opportunity to introduce the one of the incredible work, what I will say. Just he has honored with lot of awards. List of award is there. I will not mention the name because it is very difficult for me. I don't know this, but lot of people get employed. It is very difficult, but every award belonging to Honorable Prakash Bhagwan. Being passion of research, 24 research drugs awarded yearly under his supervision. That is very high academic achievement, but I can mention here. Such person is research. Apart from India, as well always the newspaper here, apart from always he visited other states in India. But apart from India, he visited USA, South Korea, Brazil, and he has delivered his talk as a scientist, as a professor at USA, Brazil, South Korea. This is again lot of this is there. Just I am highlighting such things. So such person is with us. Definitely, I request him and all the participants definitely they will take the benefit of his keynote address. We are very fortunate such person is with us. So again, being here, I am thankful to Prakash Bhagwan sir for accepting our invitation, and very soon he is going to deliver his keynote address. Thank you one and all.
धन्यवाद सर. आता प्रोग्रामचं स्टेटस मी ठेवलं होतं तर बऱ्याच लोकांचा रिप्लाय आला मेसेज थ्रू की वडगावकर सर जीनियस सायंटिस्ट आहेतच पण ते सच काइंड पर्सन असे बऱ्याच जणांचे मेसेज बऱ्याच जणांचा रिप्लाय आलेला आहे. सो सर युअर इनव्हॅल्युएबल contributions have elevated our nation. We salute your remarkable achievements and enduring legacy. With a great respect, I invite our honored chief guest, Dr. Prakash Bhagwan sir, whose expertise elevates this national conference to new heights.
Honorable Gopal Sinde, Joint Secretary of Civil Honorable Principal of College, Dr. Madhav Bhavani sir, Honorable Principal of the College, Dr.
Thank you, sir. Your brilliance has illuminated this conference. Chemistry, where molecules dance to unlock tomorrow's wonder. We are privileged to have Honorable Sri Gopal Sindhe sir, Joint Secretary, Shikshak Sanstha, Latur, whose leadership has guided to remarkable achievement. It is now our honor to invite Sindhe sir to deliver the address.
Good afternoon, everyone. On the occasion of the inauguration of the Chemistry Frontiers and Applied Science and Technology seminar organized by Rajashri Soham. It is our honor to have distinguished personalities on the stage. Dr. Prakash Vardhavkar, our Chief Resource Person and Keynote address. He is going to give you Dr. Satish Patil, Dr. Vasawa, Principal Gawani sir, and Principal Singh, organizer Professor Dr. Parke, and all the members of the organizing committee. I would also like to congratulate all the professors in the field of chemistry, the students and aspiring scientists in this field who are going to get a great incentive, or we can say the knowledge from the available resource person. I wish you all gain from this, and the Sanstha is privileged to have all you in this premise. Thank you.
Thank you, sir, for your insightful words that chart our path ahead. Now, I would like to call Mr. Akshay Bhandare, sir, to propose over things.
Good afternoon all. I am here to propose vote of thanks. Respected chairperson, honorable dignitaries on the dais, distinguished keynote speaker, esteemed guests, resource persons, respected principal sir, vice principal, colleagues, researchers, delegates, and dear students. It is my proud privilege to propose vote of thanks for inaugural session of today's National Conference on Chemistry Frontiers in Applied Science and Technology, organized by the Department of Chemistry and Analytical Chemistry, Rajashri Soham Mahavidyalaya, Latur, an empowered autonomous institute under the sponsorship of PM-USHA. Firstly, I express my deep sense of gratitude to our honorable chairperson, Gopal Sindhe sir, Joint Secretary, Shri Chhatrapati Shiksha Sanstha, Latur, for inaugural constant encouragement and visionary guidance. Thank you, sir. I sincerely thank to our inaugurator and keynote speaker, Dr. Prakash Vardhavkar sir, Professor and Eminent Scientist, CSIR, National Chemical Laboratory, Pune, for his inspiring and enlightening address. His scholarly insights have truly set the tone for the conference and enriched our academic understanding. Thank you, sir. Heartfelt thanks to our respected principal, Dr. Mahadev Gawade sir, for his motivating welcome address and for his unwavering support in organizing this academic event. Thank you so much, sir. I am also grateful to our Vice Principal, Professor Sadashiv Shinde sir, for his valuable presence and guidance. My sincere thanks to Dr. Dhananjay Palke sir, Head of the Department, for his convener's address and his leadership conference success. Thank you, sir. I would like to thank all the resource persons, speakers, researchers and participants who have contributed through their presence, papers and discussions, thereby making it stimulating and fruitful. I take this opportunity to appreciate the organizing committee, teaching and volunteers and seamless coordination throughout the event. I gratefully acknowledge of PM-USHA for sponsoring this conference, which has enabled us to organize this academic gathering successfully. Last but definitely not the least, I thank to everyone present here for sparing their valuable time and for being the integral part of this today's program. With these words, I once again express my sincere gratitude to one and all. Thank you very much.
असं म्हणतात, आभाराचे भार कशाला आणि फुलांचे हार कशाला, आभाराचे भार कशाला आणि फुलांचे हार कशाला, एकमेकांच्या हृदयात राहू त्या घरट्याला दार कशाला, त्या घरट्याला दार कशाला. With kind permission of chair, we declare inaugural function is over here. Now we proceed to start a technical session 1.
I appeal to participants to not leave the VLC hall.
Once again, good afternoon everyone here. After our inaugural function, we assemble again. Instead of keynote address, we are going to start first technical session first. Some reshuffling in the program because of some head schedule of our resource person. We have changes. We have made some changes in their scope. So instead of keynote address, now we are going to start technical session. And again, I have taken this opportunity to introduce the person, and actually it is proud for me, I will say. It is a proud feeling for me. It's my pleasure. The person who is seated here, with whom I have spent 2 years in Aurangabad when we studied MSc Organic Chemistry. He is Dr. Satish Patil, and we are the classmates. We have studied together in 1990 up to 98, and he is master in organic chemistry actually. During discussions, definitely I agreed, I improved myself as far as the organic mechanism is concerned. Because I never forget that 2 years. At that time in hostel, I think, do you remember, sir? Yeah. What is that? In hostel number 1, and even in botanical garden, a beautiful garden in Aurangabad University at that time. So strong, healthy discussions. Always we what we had discussed together. Satish Patil among them, Anil Chilage, these are all colleagues we have studied together. So it's very pleasure for me to introduce the person, Dr. Satish Patil, and already principal said he is alumni of the college first. It is privilege for us. He studied BSc from our college, then migrated to MSc for Aurangabad, completed in organic chemistry, then long journey starts. He never stopped. Just we joined the duty, but he joined NCL for the research work. And he is master in polymer chemistry. Principal said how his work in solar particularly. So with us Satish Patil is here, but definitely I have to mention some points. Native place, very close to me. I am from Bivani and he is from Bharki. So the distance also very close to us. Means overall he is from our area. Now he is head professor at Indian Institute of Science, Bangalore. As far as the research journey is concerned, he is from I think 2017 he is professor. Before that, obviously, he is assistant professor, then associate, but now promoted as a professor from 2017 onwards till now. As far as the contribution to research is concerned, he is honored with various awards. Just I will mention some point here. He honored with the Suvarna Jayanti Fellow of the Year, Fellow Indian Academy Award, INSA Young Scientist Award he achieved. Again, similar to our respected keynote speaker, he is also a lot of this again here. What he got the awards, I will not mention some. Again, he is the editor of the some board of members. Lot of papers again. Here that what he published in the national and international journals. So it is big event for us, definitely. And again, I am thankful to Satish Patil, who has given consent to come here after long journey. Almost 20 hours he drive the car and came here. So it is very difficult, but definitely he is here. So on behalf of department, I am very thankful to Satish Patil sir. Now I am request you to proceed the session. But before that, so as per the protocol of the technical session, may I request Yuvraj Sarnikar sir, who is HOD of the Department of Science Science College, please take the chair. He is the chairperson of the technical session. May I request again Sarnikar sir to come on the dais as a chair. Please, sir.
I would like to request Dr. Momin sir to felicitate Yuvraj Sarnikar sir, HOD of Department of Chemistry, Dayanand Science College, Delhi. May I request Dr. Satish Patil sir to enlighten us with your knowledge.
Okay, all right. Thank you. So for me, it's like, oh, yeah, okay. Yeah.
No,
Yeah. Everybody can see that? You can come this side. Come this side. All right. Okay, everybody can see the slide. All of you? Okay, good. Okay, good morning. For me, it's like coming back to home. Right. So I studied here, and I have a lot of memories of this campus. This was a very beautiful place. I studied here in 93 to 96. Okay, that was right after my plus 2, I joined here for BSc. That was in chemistry, and I had wonderful teachers. And one of them is Professor Palke, he is sitting here in the audience. So he taught me organic chemistry. And I had like really wonderful teachers. So still I recall their memories whenever I go in class and teach like undergraduates from coming all over the place in India. But I always remember the kind of lectures these people are giving. Because these people had very limited resources, right? But they were very dedicated people. I think there's a difference between a teacher and researcher.
come all the time to teach students, and they were very, very closely connected to us. So whenever we end the class, they will take it for a cup of coffee. There was a door here in the back side. I think many of you must have not seen that door. So we go for a cup of tea and chat. We share everything our life about how personal affection for a teacher was very, very close. So I have a lot of stories. Sometimes I can come and can share with you, but today in the interest of time. And I had again privilege of giving always lecture with Professor Vardamkar. He has been a very inspiring figure, as Momin mentioned. We have, there are many people in always help in life. Okay, as for students, please remember that. Right, these small events triggers your life and takes you to anywhere. Okay, and these are some of the stories where you should certainly get inspired. When I just walked in National Chemical Laboratory, it's a story of basically people coming from this part of the world. Always they was a little bit not looked at very judgmental, right? People see that, okay, can you really speak a good English? Can you really communicate with people? Can you talk with people? But he was the one who always came out of his office and always talked with us and encouraged us to do that. And so far, whatever I am here standing with, all the contributions come from many people, including my own parents, actually. So I will not really talk to you again. Yeah. So yeah, please come front here. I think please listen. Okay. Everybody else will keep quiet. Okay. Don't talk among yourself. Otherwise, point out from here. Okay. All right. So you see that I'm going to really speak about not much of my research. If I start talking about lot about my research, then it will be very difficult to follow it. For example, if some of the topics which we work is slightly advanced and it's very hard again to get connected to me. So what I will write is, as Professor Vardamkar really mentioned, about chemistry is the central science and why chemistry is the central science subject. As a chemist, how do you connect to the other branches of the science? Like for example, physics, material science, nanoscience. But chemistry plays a very important role. So I have given a very broad title, organic electronics for organic materials for molecular electronics. So I will explain each term. What is molecular? Is how there Okay. All right. So this is the word. Perhaps I think all the students, I want them to pay attention. Something called molecular electronics. Okay. How do you use as an organic chemist? Momin mentioned, and make something called molecular electronics. How to read it? For example, I have a cell phone in my pocket. Right? How chemistry plays a role in cell phone. You may be really surprised to see my couple of slides saying how chemistry played a role in cell phone. You may not have, many of you must have not even realized that, how chemistry plays a role in cell phone. So this is what I'm going to talk about it. Quickly for a couple of slides, I will give introduction to the institute where many of you are aspiring to go for institutions. So this is my acknowledgement, and again grateful people. BSc was 1996. There are many wonderful teachers. So this man, James, especially, I think I wanted him to be an audience, but he couldn't really. Is there? Where is he? He's coming. Okay. He taught us a organic chemistry. The way he will ride from one boat to the other boat. Beautiful teacher, wonderful teacher, right? And then Saturday, Sunday, he will go and work in the field. He will come back and he will teach us. So I think he was extraordinary organic chemistry teacher, since I remember. Okay, throughout my life, of course, Palke came with the party, Chem-FAST, many more. So I have not. The list is very long, so I have not really put everybody's name. But these are the people who really made shape our life. So this is the institute. Okay. You all, as an Indian, you should all be very proud of. This is one particular institution was established in pre-independence era, right? So that time you see that 1909. So it's more than 100-year-old institute. This is again pre-independence era, but not supported by Britishers. The main tower building looks like a British architect, but however, Jamshedji Tata. Okay, we all were very grateful to Tata. Tata have done some remarkable service, the nation building service in the country, but they have funded this institute. He established, and he was the Maharaja of Mysore. That time you see there were kings, different parts of India, pre-independence era. And here Maharaja of Mysore was very small, tiny child. His mother donated the land. So we have a right inside the city of Bangalore, 400 lush green campus. Beautiful place. Whenever you are coming, you can visit us. And these visits matter. Okay, as a student I have visited. Okay, now I am faculty there, but as a student I have visited this place. So you see that why this institute is very special. It was conceived in 1892, shortly after the research establishment in US such as John Hopkins in Caltech. You see that this is a major top 10 tier ranked school are established in America. Same time this gentleman thought about it, we should also have institutions at that caliber. It's extraordinary contribution to the nation. So again this is higher education, but again chemistry was the first department to start in IISc. You see that now the legacy. We have, how many Nobel Prize we have in physics? How many of you know? At least the name is there, very obvious, right? Sir C.V. Raman received the Nobel Prize. That's a complete work done in this country. Nothing was done outside the country. Okay? He took wood and he started diffracting the light because there is no facility in the laboratory. But then he used simple wood. So that's a very inspiring story. Right? Because we all think we don't have advanced facility as well. Today he was very creative. He just took a wood and he did, this is the first, but then he was the first Indian director. Because the institute was pre-independence, so we always had the British director. So he was the first Indian director, then Homi Baba. Again, EIFR is many institutions you know, because Sarabhai Desi goes, he went and founded first IIT actually. One today we have wonderful institutions of IIT. Satish Dhawan was the first chairman of Space Research Organization. So entire ISRO was established in IISc. Alright? And then Professor C.N. Rao, of course, everybody knows that. He was again a very tall figure in the science. So we have division of chemical sciences, electrical sciences, this is all everything available on the website. So in the interest of time, again I will not spend time. So this is the institutions. Okay? What is the name of the institutions and what it belongs? So everybody now onwards, I hope that you should know what is IISc, right? People always mispronounce saying different names. But it's called Indian Institute of Science. So also we have engineering departments also. Now let's go back to the science. What is chemistry now? How do we practice chemistry to shape the human, human civilization? Okay, I want everybody pin drop silence now, please. Okay, so this is how materials shape human civilization. Let's look at now. We all have computer. Everybody is literate about computer. This is world's first computer. You see that the room required bigger than this to store single computer. And then you need multiple people to operate that computer. Now I'll just look at today's computer. Is today's computer we can hold on our palm, right? Very tiny piece of computer. This was required massive power to run this computer. This requires very minimum power and it is a very fast supercomputing machine. Today we can access all over the world's information by connecting here. So we'll connect to the world, right? Then I will actually come back to you how chemistry played a role there, right? It's all again integration of chemistry, physics, many other branches. But however, how organic chemistry played a role here. Similarly with cell phone. You see that? This is Dr. Cooper. He was delighted to talk with his colleague next door. This cell phone had a weight of 3 kilogram. 3 kilo, right? Can you carry 3 kilogram around? You need a backpack to carry the cell. Now what happens to this cell phone? Right? Many of you have this cell phone. I know iPhone is very famous in this country, and many of you have iPhone. You see that this is less than a gram. You see this is iPhone, but I have, right? It's a very small, tiny one. You see that this transition. So we blessed today with materials chemistry, the transformation from here to here, here to here. Our world has become very convenient now, because I still remember when I first landed in Germany in 2000 to To speak with my mother, I had to wait for 1 week, right? There was no cell phone that time. You can't really connect with me. So it was very hard, but now I'm very happy when I come out of my apartment early morning, the security guard makes video call to his mother, right? So it's a blessing, right? Because we connecting to your parents, whichever the part of the world, is a big blessing, right? So it has pros and cons. Everybody is complaining about kids are only talking on phone and playing phone, but technology comes up with pros and cons. There is a major benefit. So on the cell phone, you have a beautiful screen. Actually, you see that it is now you don't carry camera anymore. You take clicks picture by using cell phone. So this screen is made with organic light emitting diodes. It has organic material integrated with this one. The science part of it is very complicated. Again, I will not spend time explaining that. But however, you see that the screen is made with organic light emitting diodes. So you have beautiful visuals, displays, and organic chemistry again played a very, very important role by doing this. So this is what actually materials chemistry played an important role. Give one example. Sort of giving example, I always say that how human civilization has been shaped by organic chemistry or materials chemistry. So going forward, so this is what I say, role of chemistry, semiconducting material. You have everything here is silicon. So you know periodic table, if you look at, silicon is the key element. In all these devices, silicon has all transistors, whatever we have in this cell phone is made up of silicon. Okay, and then understanding crystal structure, doping mechanisms, which actually is very important. So the Nobel Prize is, okay, now let's open cell phone. What is inside the cell phone? I think you must be very curious about what is inside the cell phone. If you just have a cell phone which is not working, open it. You can do that exercise, of course with some safety protocol in some classes, but you can open it now. So I start thinking about it. You see, open the cell phone. This is the way it looks like. These are the main components in the cell phone. It has many, many components. But does cell phone was born overnight? No. It is a work of, again, pioneer work of a generation of a scientist who have worked very hard. Camera, 3 Nobel Prize awarded in physics for blue light emitting diode. So this is for the physics. You see that radios, 2 Nobel Prizes awarded for physics. Communication was, sound quality is extremely good now. You don't see that kind of quality. You see the computers, 3 Nobel Prizes awarded again for physics and many, many more. Okay, GPS location. We never ask address now, right? It used to be traffic jam. You have to pull your windshield down and you have to ask people where to go. Now you can go any part of the world, right? So this is again a big blessing. Where GPS location through satellite, Google Maps work. I think since I come, so that's exciting, right? Again, so if you can come like this with the energy problem, if you can solve as a chemist, then you have a wonderful, wonderful, unlimited opportunity to look at this one. And this is actually my analysis was old, the 2022 McKinsey analysis, is organic LEDs. So you see that, okay, I will come to the light actually a little bit later, but actually you have to follow with the time also. I think Professor also has to do it, right? Yeah, so you just tell me whenever I have to stop. Okay, going forward, I talked about already display. You see that? This was the television I was talking about. Okay? So, it's a very beautiful story. We had, when I was a small child, there's something called Ramayana. People used to run on Sunday. Right? Ramayana was very, very popular. And in our village, we had only one television. And we all kids used to run to somebody's house at 12 o'clock on Sunday to just sit down and watch Ramayana. So this is CRT. Now you see that today you are watching all football matches, cricket matches, where you see the clarity of the vision is extraordinary, right? So this is what evolution of a display information. Similarly, when you go light, okay, this is again very slide. Actually, I really spend a lot of time motivating students. How do you think about it? Why do you want to become a scientist? Okay, how scientists think about it? Okay, this is again incandescent lamp. I will little bit talk about it in the next slide. You see that this has something called here a tungsten filament, right? So you heat and glow the light. Okay, when you are heating and glowing the light, you don't heat here now, right? It is a change in the lighting technology. So you heat and glowing the light essentially means you have loss of 60% of energy. So you don't really make use of entire energy, input power to make it, and we are an energy efficient country. We need power. So this is the way the mechanism works. It was developed by using tungsten lab. You see that these numbers may not be true, it is got from internet. 40 watt, 1000 hours. Depends upon how stable power. I keep telling again our village stories because whenever we never had a stable power. So this lamp, just put it there, it shot, tuck, in a minute, right? Because it will just make a noise. And this lamp has been integrated with vacuum. So that's the way this works. But today, we use fluorescent light. I think this all rooms are now. You see that? Eventually, we are going for LEDs. You see the power? 10 watt, 10,000 hours. Massive saving. You are giving small input, but using the energy for everlasting. Very long. Right? I think I don't know many of you have gone to purchase this light. When you go to the shop, at least many women have certainly, they are very careful about electric bills. They pay the electric bills in the house, right? So when they go to the shop and buy this lamp, they write here warranty. They will say it will last for 6 months. The shop owner is very confident. This guy was never confident, even though it cost for 10 rupees. You see this LED came 10 watt to 1.5 watt, and the hour is 50,000. You can use everlasting. To change the light once, it is forever, right? So this is, but now let's look at the cost. Can we really afford it? This one, 300 rupees, close to 200 rupees, and this one, somebody should tell me the price, 10 rupees, right? So, but any daily wages, right? For example, people who have bread and butter, sort of 50 rupees they make it. Lot of people in our country make very less money, right? So then such people will never appreciate the fact that you are giving him a LED light of 300 rupees. They will always say give me 10 rupees, right? So it's again responsibility to the scientists of my generation, right? We work on this area very intensively in my lab. And I say, Bangalore, how to make LEDs cost effective, cheap, 10 rupees, right? This is a big challenge. So this has all integrated with semiconducting technology, where this cost comes by the fact that there is a lot of investment. Okay, when you make this one. Now the challenge is, can you make LEDs for 10 rupees? So this is the biggest challenge. And we all actually hope that can you make it cheaper and better. Any technology, the role of scientists is to make world better than yesterday. So scientists have to work, make sure that these things are available for everyone. It's not only available in a very modern world or civilized world, it should be available across the globe for everybody. So this is one challenge I think perhaps your generation will have if you want to become scientists and get into this field. It's very exciting, right? So you are directly helping sort of people how to do. So who invented this? Somebody thought it, right? So again we have to, unfortunately, because inventions are very few in our country. Hopefully that things will change by going forward now. But you see that who is this guy? Student? Anybody? I will again ask from that side. Who is this person? Anybody? You see? You should know, right? You all are preparing for IIT, JEE actually here, right? Very good. Who said Edison? You said? Okay. This is Thomas Edison, right? So Edison thought about it. Actually, these are the pictures where, when I was visiting London to his museum, these are some of my own pictures. I took few pictures when I was visiting there. It's very inspiring. He looked at this one and he looked at the entire periodic table, saying what is the element you want to use it, how to make light actually, right? So then he sort of screened out why incandescent lamp is so cheap, right? He took just a carbon fiber, simple carbon fiber, and he glowed. And this, look at the light. He was applying vacuum in a big glass chamber, because when you are heating something at very high temperature, you don't want oxygen and water to react, otherwise the life is very short. So you want to heat something in vacuum. So that's basically the idea. So Edison invented this carbon fiber. You see that? In fact, his first conference he went and he presented his first paper saying, I have light. People talked about it. What kind of light do you have? Because there were people not used to with light. His efficiencies are lumens per watt. 1 lumens per watt. It means it's like a candlelight. Everybody mocked him, saying that this is not going to be really work in a real world because it is not bright. Right? It is not going to brighten this entire room. But however, Edison, thanks to Edison, as of today, we have light in us. And he discovered this wonderful. See, this is something you can do as a scientist. Your legacy will last forever. Like generation of people will talk about you actually like what you invent in life. So we are always grateful to Edison. Like still now we take his name because he invented actually this ink kind of thing. So few again example I will keep giving it, and then this is I'm emphasizing by the fact that how chemistry plays a role in this kind of a research. Now what is statement? This is very profound statement. For a scientist, we always say that actually my students when they join, they say okay, when they fail in doing experiment, they come back and they are very upset about it, very unhappy about it. But he made a very profound statement saying that I have not failed. I have just found 10,000 ways that won't work. Right? Means he was not afraid of failures. Right? Every day we want success. By the time we go home, 10 different stories we want to take to home. Right? Otherwise, Edison was not like this. The scientist, you have to be prepared. But we be prepared for failures more than success less. Right? People talk about H-index, this citation, that. Don't even go close to that. That's, most of the things are fake. Don't even think about it. You want to make my H-index is this, my H-index is that. Alright? If you want to become a true scientist, you have to really follow the journey. Right? It's a very sort of philosophical journey. You have to be very deeply think about it and what you want. Right? It itself is a path. So otherwise, citation doesn't matter. This is the impact you want to make in the world, and this is big. Right? Okay. So, like now, I will come back to the kind of thing, a little bit what we do in our lab. We use polymers. We use plastic semiconductor. Again, you must be very surprised that why plastic is a semiconductor. But indeed, plastics are semiconductor. There are particular class of plastics are semiconductor, not all plastics. So you see that cable is running throughout this entire room, which is a copper wire. It carries the electricity, but it is covered with plastics. So you avoid the electric shock. So you must have a semiconductor, and they really are soluble in common organic solvent. As they were organic chemist, you correlate to this one. And now we can coat on any surface. So as a result, you can make things flexible instead of very rigid. This is very rigid device. But cell phone, flexible cell phone, you fold it, keep in your pocket. That's a flexible cell. How do you make that? Essentially, you make out of ink. You see how do you inkjet printer you have seen, all of you, right? Imagine you are printing transistors, a large number of transistors on a piece of paper by using ink, semiconductor ink. So that means this is the role of organic chemist now. Okay, this really inspired me of this as a because by training I'm an organic chemist. So this inspired me how we can do the research here. Right? How we can make a big difference by using a semiconducting polymer, which are very bright and colorful, and you can print down any surface. So now if I want to make those LEDs are why these LEDs are expensive, because you use fabrication methods which are like you need clean room, you need a big facilities to make it. So as a result, those LEDs are expensive. So if you make LEDs out of this thing, or solar cells out of this thing, better solar cells than what we have on the rooftop, everybody will use it. Right? They become part of the building rather than integrating on the rooftop. And you require very limited maintenance for this. So this is the semiconducting thing we work on. Let's see what all things we have. So now as an organic chemist, we start thinking about it. Actually, what are the materials you can make it with the lab? There are certain bunch of polymers, small molecules like Buckminster fullerene, you can see that here. By inventing this one, people got Nobel Prize again. C60, carbon 60. If you are a chemist, you correlate with all these carbon-based structures. You use this material, some of them are polymer, macromolecule, gigantic, like a DNA. You can think of how big it is, right? You have multiple units, large, gigantic polymers. You can think of and use those as an ink to fabricate the device. So that's what we do in our lab. We just use the chemistry, fundamental core organic chemistry as a theme of the research. We take this one and start making it how to make electronic devices out of it. So it's very simple, right? You don't have to really very good, but of course you should know a lot more. You can't be just very only chemist. It's again when you start struggling with the concept, right? Which I have explained until now. It has involved concept in physics, it has concept in electronics, but now your core area is organic chemistry, right? You're making difference by making these molecules. You're making wonderful LEDs, wonderful solar cells by learning organic chemistry. So that's the main idea. So this is, we can do it polymer also. As I mentioned, there are very special class of polymers as semiconducting. You can ask me the question, I will give 5-10 minutes in the end. Actually, you can always open up yourself and ask the question, why plastic is semiconductor? When this discovery happened as a plastic, as a semiconductor, they also got Nobel Prize, right? This was in 1977. Perhaps I was just born that time. Okay, 77. Somebody said, I use polyacetylene, and that polyacetylene is semiconductor polyacetylene. And this is, you see that? These, as I mentioned, is a special class of polymers which are semiconducting, which has alternate single double bond, alternate single bond. So the basic fundamental hybridization of the chemistry works here. Okay? So if you know what is the sp3, sp2, sp hybridization, actually if you learn hybridization, then this is a simple class of material which has single bond, double bond, single bond, double. This is the only material which can have electron density across the backbone where they can carry the charge. As a result, they become semiconductor. So it's a very crude explanation. I'm not going very technical. Otherwise, you will lose the link what I'm talking about. Then why these are important now? You take this material, make all these devices. You make LEDs, which are foldable, better LEDs. You make cell phones, which are again foldable. You need minimum power to run the cell phone. Now it is lasting for 3-4 hours. You want to make it last for 10 hours, right? It's a lot of saving of energy. Today's world, people are outcry about how energy deficient our country has become. But however, if you start using this kind of a plastic, you can really make solar cells affordable for everybody. At the moment, solar cells are affordable for a small number of communities. But however, if you make solar cells, okay, this is what it is basically talk about. Okay, polypyrrole, polythiophene, many bunch of polymers. So okay, so this is again, I will not really go a little bit more technical. Why how the valence band and conduction band are in polymers, which is HOMO and LUMO, where you use highest molecular or white labor. I think this is something which you will learn. Ionization potential and electron affinity. It's very simple with respect to vacuum. Okay, how these things work. So you should have basic, again, see it's all chemistry. So students get very scared the moment they see bit of a math, bit of physics, they get backed up, saying no, I will not understand this. So there is nothing which we cannot understand. Everything you can connect, but fundamentally, if you go back and if you do the chemistry. But you should have a clear-cut idea what are the properties of these materials you are going to study in the laboratory when you are doing research. You can't just make material and you leave it there. Then it's very hard. You have to really take it as a material, study them, bit of a physical chemistry, bit of a optics, and then if necessary for very good you can make also devices. So you can do this one. And then there are couplings here, intra-chain. What is the time? Momin, how I'm going to time? Okay, you can warn me. I don't want to finish something. It's okay? Alright, and then we have to go for lunch also. After your talk. Okay, so this is inter and intra-chain coupling. Okay, so this is again now is getting more technical. Okay, so stay with me. I will try to simplify things as much as possible. So actually I understand how difficult it is to connect people when we are not in the field. But it is important again to understand. This is all about chemical bonding. Okay, how chemical bonding works here? Intra-chain coupling and inter-chain coupling. So I'm talking about coupling between the two polymer chain here. This is called inter-chain coupling. So this is coupling between this polymer. However, when I talk about intra-chain coupling, I'm talking about within the same chain of polymer. So this is intra-chain coupling. This has a profound impact on charge transport properties of these semiconducting polymers. So you have the way you have to think about it, how these transport really help. Crystalline, amorphous region, these materials are not very crystalline, like silicon. Silicon is very beautifully periodic lattice. Okay? It is a wonderful semiconductor, it has very high mobility, whereas these materials have very poor mobility. And this is exactly what I did when I just entered in NCA. Okay? Right after my master's, I started working on this field. There is one semiconducting polymer. Right? How to use plastics as a conducting material and take it and make use of in an electronic device. So this is again chemistry, lot more chemistry. You see that why they are unique. Single bond, double bond. This is ethylene, butadiene, octadiene, polyacetylene. Right? So how the band gap, you have pi bond, pi star. You see that why they are unique here. You have this. You see this PZ orbital, okay, is vacant. We have a sp2 orbital overlap. We form sigma bond, covalent bond. How many of you chemistry background this side? All are chemistry? Okay, good. Then you'll understand the bonding, right? Chemical bonding. sp2 hybridization, that PZ orbital is vacant. And that PZ orbital overlaps parallelly like this. And as a result, you form pi bond. Okay, which is a stronger bond, pi bond or sigma bond? Sigma bond is. So you have a weak bond compared to, so the mechanical property of these polymers are borne by the fact that you have sigma bond in the backbone. But however, you have a huge electron density cloud in the backbone that helps these materials to transfer charge. So that's the reason they become very unique. And then you start increasing this chain. So you make ethylene to polyacetylene, then you have a big, gigantic, long polymer, very long chain, and that gives rise to a continuous band. We call it homoendome. So the physics of how it opens the band gap, again it has pulse instability, other very involved phenomena which I teach in my class, but if I start going there, I think you will get again and lose you. So I don't want to really talk about a lot more physics of that part, how this band gap opens. But however, believe me, the band gap does open and you have homoendome. So this is what you have in polyacetylene. Very unique structure, but then we have semiconducting property. So then we will go and make whole bunch of, this is for example, you see that why chemistry is very rich here. Benzene, naphthalene, anthracene, tetracene, and pentacene. You are fusing rings and extending the rings. Simple chemistry. And here you make pentacene, you make dips pentacene. You have a soluble group. Similarly, you take thiophene and you make polythiophene. And organic chemists always want to dissolve these materials in common solver. They put these alkyl chains. These alkyl chains on third position of this thiophene. You have lone pair of the sulfur, and this position is electron rich. So you introduce these groups, and then you make some again wonderful materials. Depends upon what kind of band gap you need and what kind of structure you need. This is all about chemistry, actually. How do we really use a chemistry knowledge here, making wonderful, wonderful electronic materials. Okay? And that's going to come big way. Actually, down the line 10 years, and you see that now we have a very rich pharma industry in the country. You see, all pharma industries in our country are very, a lot of people work in pharma industry right after their PhDs. So they make these intermediates, right? Unfortunately, we do not have industry invent everything ourselves. I think our ecosystem is not ready for that. But however, they do a wonderful job. But for example, with Covishield example, what Professor Vadgaonkar gave, making that itself was a challenging for many countries. Because in our country, we made it. although the steps and things, many things were known, but we had infrastructure, right? So having that infrastructure was a blessing in that kind of a hard time. Otherwise, nobody would have said, okay, fine, we are not giving you any vaccine. So they produce in Hyderabad. They produce all over the place a lot of wonderful material. So now these material actually, so many places when I go to all over the world, I think what the greatest strength in our country is people, right? We have huge population, and that strength we can't imagine. We start making these things in our own country, and then we have tomorrow people start producing television, and I'm 100% sure in down the line 10 years, electronic chemicals industries are going to be big. We are already, many people want me to advise them on electronic chemicals. So, however, this is simple organic chemistry. Instead of making intermediates in pharmaceuticals, you start making intermediates for electronic chemicals. So this is again not much of very rocket science. However, it is just simple organic chemistry. So we just use these tellering properties and then we start changing why these are important, what are the how we can make it large area, how we make low temperature, roll-to-roll manufacturing, lightweight and transfer. I think with this now we'll sort of stop here, otherwise I will keep going forever. So I want others also to speak. So I will be very happy for spend like 4-5 minutes if you have any doubts and questions. Okay? And any silly question is a welcome question. Okay? Don't really think about it, don't shy away. That's a problem with these kids in this part of the world. You always shy away. You don't want to speak actually, right? But speak out. You feel it, express it. Okay? I also know Marathi. मी मराठी पुस्तक उत्तर देऊ शकतो ठीक आहे चलो मराठी टीचर्स मराठी टीचर okay in any language you can speak and then you can talk. I will be happy to answer the question. Thank you very much.
Thank you very much, Dr. Satish Patil sir. Dr. Satish Patil sir explained the role of chemistry as a key for the several sciences like nanosciences, material sciences. Also he highlighted IISc and its legacy. He also highlighted over the transformation especially in the material sciences and particularly the role of chemistry in development of cell phones, particularly by the development of lithium battery. He also highlighted a key word that is today's research becomes tomorrow's technology. And also he used a way or tomorrow's research path that is electronic chemical industries may be established in future. Thank you very much. And I request the students and participants to ask questions on these topics to resource person. Thank you.
Yeah, thank you. Yeah, so ask questions now. Otherwise, I'll ask you questions. Okay? Which way you want to take it up?
मी HOD सर आणि आजचे प्रेसिडेंट सार्निकर सरांना अशी विनंती करतो की सरांनी पाटील सरांचा सत्कार करावा.
क्वेश्चन नंतर you can
ओके ओके जर कोणत्या विद्यार्थ्यांना प्रश्न विचारायचे असतील तर विचारा.
Adi, let's see how well I answer the question, then you felicitate me. Okay? All right. Anybody? This side. I think people are not paying attention.
सर माझ्यापासून स्टार्ट करू.
Thank you.
I am Mr. Filoya. My question is that out of the different solar cells, is the dioxide solar cell or perovskite or the silicon based solar cell, in future, which one is the more beneficial? One question is, and if silicon based solar cell is not beneficial in future, then what is the future? What will be the future of that silicon based solar cell?
Very big nice question.
That will go in the dustbin, not directly. And the second question is that if we utilize the different dyes, so if we increases the number of double bonds, which is used for the excitement, so either it increases efficiency of that solar cell or it does not affect on that solar cell.
Okay, alright. Okay, so good question, right? I think at least when you go out of this room, everybody is going to look at that roof. That is the solar cell, right? He's asking that why can't, what is the current technology available, right? Current technology is based on silicon, but silicon cannot be integrated across the globe because we have needed terawatt scale power to lighten the world. Actually, for example, you see that in the night, you make it, we humans have created artificial light to replace the sunlight. And the night, you see that, but however, we have a difficulty of integrating silicon. The problem with the silicon is, it is first of all, it's an indirect band gap. It's a technical term. You can look at it in the internet. It's a very poor light harvesting material. Okay, you don't harvest a lot of light. That's why you use very thick cell, bigger, right, and heavy. Whereas these polymer-based cells are made with perovskite or other new cells with a direct band gap semiconductor. You can use thinner cells and you can integrate. But question of how robust these cells are. Anything you buy today in the market, the first question is I will ask is how long they last. Right? So if you are putting something on your rooftop, you want to last it for 10 hours, you buy a geyser in the lab or whatever it is, right? So these cells which we are talking about, they have very poor lifetime. So going forward, if you make a solar cells which is as good as silicon, okay, and with very high lifetime, it is wonderful. But it's very hard to make that. It's not very openly people could make it. It's very challenging for a scientist to make that. But eventually, I think we will not be replacing silicon, but we'll have a really alternative technology to integrate solar cells. So at the moment, I can give you answer only that. Going forward, there will be many more advances. Yeah. Okay. He was a teacher, right? He asked the question. Now, students. Students, come one by one. Anybody? I think these three guys were all in court. They were listening to me at least. I could make it out. Okay. At least they were paying attention. Anybody from here? Please ask. Anyone? No? Then I think I have not done a good job. Right? I have not motivated you enough. You know, there is no curiosity driven question. Anything what you think in day-to-day life, how science has been utilized. See, I was mainly trying to connect you through that. I just did not even show one, not even a single slide from my lab. What research we do. Okay, generally I just don't do like when I go to colleges. The idea is to motivate you and connect in day-to-day life. So what is any other questions to anyone? No? Marathi Vichar? No? Please. Good. Very brave girl actually. What's your name? Can you identify yourself? See, I think now she will trigger the question. Anyone will ask. Okay, please go ahead.
Hello. Thank you for the interesting talk, sir.
Thank you very much.
My question is, how does plastic behave as a semiconductor?
Let's see, because it's a very, very important question. She caught me, actually, right? Technically, plastics have not semiconductors. I was leaving open-ended ideas for you so that you ask the question. Plastics become semiconductors. If you look at my slide here, you see that here I was explaining you. These are special class of plastics which has single bond, double bond, single bond. Your answer is here. They have sigma bond and pi bond, and you dope them. They act as their insulators. After doping, they become conductive. But not all plastic. Plastic bucket or bathroom is insulated, it doesn't give electric shock, right? Otherwise we all will be in trouble. So there are special class of plastics are semiconductor. That's a revolution. It's a very big thing, right? Because using plastics are simple, right? We can use it coated plastic. But not all plastics are conductors of electricity. Unique property of this chemical class is become. See, so how deep technical questions she asked me. I think you others should now, at least you should inspire. Right? And it is very well articulated. Very well. Thank you very much asking for that. Anybody now? No? Last row, should I ask a question? No? Any teacher, anybody? Please ask anything. What doubt you have?
May I request to Dr. Sanika sir, HOD of Dayana Science College, and now President of this session. May I request to felicitate Dr. Patil sir. Thank you very much, sir. After this, we will take a 2-minute break. After that, next session will start.
afternoon. So, of course, there is a change in the order. So, some of the points which I wanted to cover in my keynote address have already been covered by Professor Satish Patil. That only shows that, the importance of the topic. So, there is some overlap which is inevitable, which emphasizes that the topic is very important. So, what I am going to do in the next 45 minutes or so is to tell you about how we can, secure our future, because all of us are concerned with our future, right? And of course, like I mentioned in my inaugural address, and also was emphasized by Professor Satish Patil, technology is the order of the day. Okay? We all live in a technologically driven world, and whatever the comforts we are enjoying today, thanks to the technological development. But when we talk about technology, at the base of it is the science. Like I said, today's science is tomorrow's technology. That's why the fundamental science is very, very important, and that's why I would like to congratulate, the organizers for choosing the theme, which is highly relevant, okay, and apt for this occasion. Of course, when we talk about securing the future, the bright future for all of us, the future, should be created, not predicted. Because, they say that fools predict the future, while the wise men create it. Okay? And who creates the future for us? Scientists like Professor Satish Patil and so many of them. Okay? So we should be again grateful to all those scientists of the yesteryear who have created the future for us. Okay? And now it's our responsibility to make sure that the future generation also enjoy the benefits which we have been enjoying. Like I said, he did mention, whenever we find a solution to a problem through technology, it comes with 10 new problems. And I'm going to illustrate this point. This is a rather paradox, but it's very true that whenever we find a technological solution to a problem, it creates 10 new problems. That's why, the job is always on hand for scientists, because they have to take care of the 10 new problems, which are associated with any new technological development. Again, talking about, the interdisciplinary or multidisciplinary approach. Friends, let me tell you that, all the simple problems in science and technology have already been solved. Okay? What is remaining to be solved is the very complex problems. These are not like puzzles, but they are the problems. And if you really want to solve those problems, and I'm going to give you the list of challenges which the world is going to face. And it is for you, the young generations, they have to deal with it. Okay? To find solutions to this problem for the very existence of ours, the humans. If you don't, address those issues, then our future is in the dark. Okay? Like, people think all the technological developments have taken place, right? Like, man has put his foot on the moon, right? We have all these mobiles, communication revolution and whatnot, agricultural revolution. But problems are still there, and in order to address those problems, we need technological solutions. And in order to develop technologies, we need science, and again, we need an interdisciplinary or multidisciplinary approach. It's not that only chemistry can solve all these issues. Okay? We need expertise or inputs from physicists, biologists, even social sciences. Okay? That's what that we need an approach which is integrated approach. We should not be working on silos. Okay? We need inputs from all of these disciplines of science and technology in order to secure the future which is sustainable. And I'm going to spend some time talking about what is sustainable future. So the agenda for my talk is, since this was a keynote address, and I wanted to keep it very simple, since I see that, there are a lot of undergraduate students who are sitting in the audience. First, let me tell you what is the central role of chemistry in our society. Okay? As I mentioned, chemistry is the mother of all sciences, and as defined by Professor Ronald Breslow, I don't think I need to tell this audience who Professor Ronald Breslow was. he defined chemistry as the central science, creative and useful science. And I will explain to you the meaning of all these terms, how the chemistry is central, how the chemistry is useful, and how the chemistry is creative. Okay, but there is not all is well with chemistry. Okay, and as a scientist, I think we have to be honest in telling the younger generation that chemistry has indeed created certain problems or certain issues. Okay, and what those issues are or what those concerns are, I'm going to list them out. Okay, so and one of the most difficult problem in today's world is the resource scarcity and the waste generation. I think these are the two mega problems which the society has to address. So where the resources will come from, or the chemicals, or like you mentioned, the materials which we make use of. Okay? So it is dependent on some source, and the sources are finite. Okay? So we have to make intelligent use of those resources what are available to us. Okay? And another important point is the pollution which is created due to human activity. So there is an urgent need from the scientific community to address the issues which are created by pollution. Taking an example of plastic, it has created white pollution. Okay? And for that matter, when the intended use of any material is over, it becomes a waste. Okay? And in earlier days, 50 years before, people did not give so much of consideration to the waste, okay? Because the resources were available. But I think now time has come, we have to worry about where these materials will come from and what you do with the waste which is generated. Okay? This is again the task at hand for the younger generation to tackle those issues. Okay? Of course, chemistry is so important, and I'm going to give you some statistics that 95% of the manufactured good are dependent on chemical industry. Okay? So that's why chemistry is central, and of course new chemistry is essential. Okay? Chemistry is not going to go away. Friends, let me also tell you that though there is so much of bad name which chemistry is associated with, but chemistry is not going to go away, because all these complex issues or the humanities challenges can be addressed only through chemistry. Okay? So how chemistry is directed to address those issues, I'm going to give you certain examples. Okay? Now, of course, therefore there is a call to action, that is reconnect with nature through innovation. Okay? As you know, Mother Nature is a great scientist. Okay? In nature, there are cycles. The materials are produced and then they are recycled. And I will give you those examples of how Mother Nature makes sophisticated molecules or complex structures through in its own way. But there is absolutely no pollution in Mother Nature. But when we talk about the products which we make in the industry or chemical industry, there is always chemical industry is associated with pollution or environmental degradation. So we need to change the course of action. Okay? So we have to follow Mother Nature. That is, the principle is with the nature and not against the nature. I think that is the message which I wanted to pass on to the young generation. So it's very much possible that we can do chemistry, but following the principles what Mother Nature follows, okay, in producing those chemicals. Okay? That's why the education of students is very, very important. Now we need to educate the students for the complexity, because friends, today we live in a world which is very, very complex. The life was easy in earlier days, 100 years before, but today the life has become very, very complex. Okay, and we of course know everything around us changes. In fact, what they say that change is the only constant, meaning everything around us is changing at a very fast rate. Okay, in fact, technology also become absolute. The products become obsolete after a few years. Okay, so everything around us is changing, and the life also has become uncertain. Again, I go give you the example of COVID. Okay, the life has become uncertain. So we have to, and we all are vulnerable. Okay, that's why what is important is to be resilient, meaning the ability to bounce back. Like how the rubber band, if you stretch it, it snaps back, when you remove the stress. Okay? So we should be like that, or the trees, how they stand tall, even in the storm. So that's what is the resiliency is. The students have to be not only strong, but they also have to adapt themselves to the situation, and also to the factors around them. So this is what is the resiliency, and we need to convey this message to the younger generation. They have to be resilient. We owe a lot to these all great scientists. Of course, the list is too long. I cannot, in such a short presentation, give credit to all of them. But they don't need any introduction, I guess. You all are familiar with what these scientists have contributed. But the most important point is, their work, meaning their research, inventions, discoveries, or innovations, what they made. Of course, there is a slight difference between all these terminology. Again, I will not get into all those nitty-gritties of it, but their work has changed the world and made it a better place to live. Like I said, we should be grateful, thankful to all these great scientists, who brought about or who developed science and which led to the of urea, which brought about agricultural revolution. Penicillin, it changed the field of medicine. Okay, and also the polymers or plastic. I'll come to that. There is a lot of debate or negative publicity about plastic, but plastic is also considered as the top 5 invention. And what Professor Satish Patil mentioned, LCD, liquid crystal display devices. Okay, and contraceptives. These are considered as the top 5 inventions which chemistry has made. Now you sit back and think, if these inventions were not there, what the world would have been? We will not have all these comforts what we are enjoying today. Okay, so that's what the importance of chemistry is. Okay, and we should be grateful to all these scientists who discovered those principles or which led to the technological advancements. Of course, again, I would have to give this quiz to students. What is the first chemical reaction which was ever done by man on this planet Earth? What was that first chemical reaction? The lighting of fire. Lighting of fire, as you know, it's a chemical reaction. And what were the early technologies? Like, we have transformed from caveman to the modern man, right? Earlier it was like, iron age, steel age, correct? So today we live in the world of plastics or polymers, So all those eras are dominated by materials, and that's what Professor Satish Patil also mentioned, Materials are very important. We live in the world of materials, we need materials, for all these technological developments. And this, of course, the history, I will not get into all of this, but many times you don't realize farming is also a technology. Lighting of fire and the invention of wind, which marks the era of industrialization. So these are the 3 foundational technologies which were invented by humans and that changed the face of civilization. Okay, farming, lighting of fire and wind. And why is it so? Necessity is the mother of invention. Okay, so whenever humans are pushed, to the wall, they come up with some kind of inventions. Now, of course, again, he gave a on account of all the technological developments. But this is what the history of journey of inventions and technology is like. In earlier days, from pottery to brickmaking, stone cutting, spinning, weaving, then the engine, light bulb, telephone, radio, aeroplane, television, internet. Okay, but these are all incremental developments. Okay, where actually machines needed command. We had to give commands to the machines. But now you'll see the kind of developments which are taking place. these are the technological developments, okay? These are called as disruptive technologies. They bring about the radical change. Again, I need a separate lecture on this, what this disruptive technologies is. And you can see here, the time for those invention is decreasing. You can see here, in 3D printing, first printing press came about in existence in 1448 in Germany, right? Then computer printer came about in 1953. So it took 505 years for that development. But then from computer printer to 3D printer, it took only 31 years. So you can see the technology changing at a very rapid pace. Okay, that's the point I wanted to emphasize. Okay, now you can see here, the radio. Actually, this is the time to reach 50 million users. It has reduced. The Twitter reached to 50 million, people only in 9 months. Well, the adoption of radio, it took 38 years to reach to 50 million users. Okay, this is what the impact of technology is. And as you can see in the picture, even the vegetable vendors, they are getting benefited of the technological development. So it brings the world on one platform. Okay, world has become like a global village. So doesn't matter who develops the technologies, but all the humans get benefit of those. But of course, you have to pay for the technology, because technology does not come for free. Especially when we talk about the technologies in strategic sector. Okay? So that's why in India, if we want to be really self-reliant, Atmanirbhar, Bharat, then we need to have our own technologies, and that's why we need good scientists and we need good students who are well trained. They are all round, they understand physics, chemistry, biology, mathematics, computer science. That's what the need of the hour is, because like I mentioned, all the simple problems have been solved. If you want to develop solutions to all these complex problems, we need a multidisciplinary approach, and we need our own technologies. Okay, that's what is very, very important. So these are some of the examples of disruptive technologies. And actually, all of these should be included in your syllabus. Like 3D printing, fuel cell, AI. I don't know how many of you have heard of this term. Machine learning, this is what the order of the day is. All those simple problems have been solved, so we need to have understanding of all of these fields. This list is again too long. I need a separate lecture again about these disruptive technologies. So you see how the society has benefited through all of this technological development. Like society 1.0, we were all hunter-gatherers. That's why I said caveman, right? From there, we have come to now society 4.0, meaning we live in the age of information. Okay? And of course, Japan has developed this concept of new society, society 5.0. Okay? Meaning where the physical world and the cyber world will be together. Okay? Again, this is a very different concept. I'll not spend time talking about it. But you can see here from hunter-gatherer to agricultural society to industrial society to information age. And what we are targeting is for the society 5.0. So this is the importance of technology is. Okay. Of course, technology one can develop through physics, biology, botany, biotechnology. All these these are not, by the way, watertight compartments. The students who are studying chemistry should also have background in other topics. In fact, these disciplines were developed just for convenience. But I think in today's time, like I mentioned, to solve all those complex problems, we need interdisciplinary approach or multidisciplinary approach. But this conference is about chemistry. So I would like to tell you what chemistry, the importance of chemistry is in the society. Of course, chemistry is a branch of natural sciences dealing with the chemical composition of substances. Okay. And all of you are familiar with periodic table. In fact, there is no material in this world, but there was a challenge thrown by Royal Society of Chemistry to tell any material in this universe which is not made up of chemicals. Have you ever thought of it? There is nothing in this universe which is not made up of chemicals. So that's why chemistry is a very, very important. Of course, other branches of science are also important, but like I said, chemistry is the mother of sciences. because everything in this world, in fact our own bodies, the air we breathe, the materials we use are made up of chemicals. So obviously, many students opt for chemistry because there are many job opportunities, right? Now I will tell you how many chemical substances have been produced and what is the worth of this chemical industry. It's mind-boggling. Okay. Now it all started with, like I said, the contributions of scientists, great scientists. And this is Wooler's photograph. I'm sure you know who Dr. Wooler is. He is the scientist who developed first time a synthetic chemical, that is the synthesis of urea. Like I said, Mother Nature makes all the chemicals, produces so many chemicals, very complex structure also. But earlier people believed that urea can be produced only in the kidney, man or a dog. But Wooler, he demonstrated for the first time that chemical can be made in the laboratory. So this is the actually beginning of the branch of organic chemistry. Okay, the synthesis of urea, which happened about 350 years before. And as you know, all the initial developments in science took place in Europe, not in the United States. No, in the Europe, Germany, France, and all those countries. Okay, and you see how confident Professor Wooler was. Though he didn't have all the analytical tools in those days, he said, I must tell you that I can make a urea without the use of kidney of either man or a dog. This is a thing from the letter which Wooler wrote to his teacher Bergelius. I'm sure all of you have heard of these names, Wooler, Bergelius. This is, of course, Professor Patil mentioned about Michael Faraday. The most influential scientist in the history of science. Okay, and you know what his contributions are. This is why I call this scientist profession or teaching profession as a noble profession, because you can change the world. You have the power. Meaning the scientist has the power to change the world through his works, through his inventions, through his discoveries. Because like I said, Newton, Michael Faraday, they don't need any introduction, because their work, we are enjoying the benefits of fruits of the work which they did. That's why they become immortal. Okay, they are in the forever in the history of humanity. So coming back to this, again, Professor Patil did touch upon this aspect. So chemistry is a central science, useful and creative. So chemistry is actually our life, is our future. Now how it is central? Because chemistry connects with all other disciplines, like physics, pharmacy, biochemistry, botany, geography, physics, earth science, and it is even connects to psychology. Okay? So whenever somebody has a psychiatric disorder, you go to doctor, right? Doctor prescribes the medicines related. So even psychology is also connected with chemistry. So chemistry has a place like, what our heart has in our body. It should not happen to anybody, but if you lose your hand or leg in an accident, you don't die. Correct? But if your heart stops beating, life ceases, right? There is no life. So that's what the importance of chemistry is. But I like to give this kind of analogies so people understand the importance of chemistry. It's like what the importance of heart in our body is. Okay? Of course, the chemistry is discipline that sits at the interface of science, technology, engineering, mathematics, and medicine. Okay? Now, of course, I hope now you are convinced that chemistry is a central science. How chemistry is useful, I will show you in the next slide. And of course, chemistry is something which is creative. And what, the satisfaction one can derive most is by creating something which is new to the world. That's what scientists do, when they make new molecules or new products or new materials or understand some new phenomena. That's what scientists can uncover. Okay, so this is something which is most satisfying or most fulfilling. Okay, there is no parallelism, with other type of satisfactions. Okay, so and because, like I said, chemists, with the help of those 118 elements, of course, leave apart some of the inert gases, but from those few elements, all the chemicals are made. Okay, and in fact, just to tell you, every day, the researchers who are engaged in, research pursuing for their PhD or industry, and the number of chemicals which man has made, synthetic chemicals, has already surpassed the number of chemicals which are available in Mother Nature, produced by Mother Nature. So that's what the point of creativity is. You can create something which is new, like how the vaccine was created. Okay, it saved the humanity, right, for the civilization. So that's the kind of impact one can make through the work related to chemicals. You can see industries and processes that potentially involve chemistry, like agriculture, space science, physics. You just name any industry, there is a role of chemistry. I will not get into that. This is again a list which talks about where chemists are desirable, or where they can find jobs or where they can make contributions. Okay. Now this is a slide which talks about the impact what chemistry has in our day-to-day life and also in the modern technology. Again, to cut the long story short, you can read the sentence at the bottom. Chemicals bring benefit to the society. Okay. Physics is more of a glamorous science. Okay. Physics is needed, but it's more of a glamorous. But chemistry is something which is real and which touches the lives of all of us. Okay. And here are some examples. Again we talk about the revolution in communication. You see how that woman is, how happy that woman is. You can see from her face, because she is able to communicate with her son or daughter. He is probably in the other part of the world. Okay. This was possible again through communication developments. And he mentioned about the your mobile phone. It contains 40 materials. Okay, he didn't give you the number, but there are 40 chemicals, and I'm going to show you that what those 40 chemicals are, which are present in your mobile phone. Okay. Now, I'm sure in this audience, everybody wants to live longer, right? Nobody wants to die tomorrow. Want to live 100 plus years, right? And when you think of how long your parents live, grandparents live. The average life expectancy in the earlier century, was only hardly 40-45 years. So today, the life expectancy is 72 plus years. Women live longer, 74. Men live, average life expectancy is 72. Now, how was this possible? Through your medicines, pharmaceuticals. So we have to again be grateful or thankful to chemicals. Okay, life expectancy has increased. Our lives have become more comfortable. Now we use clothes, warm clothes. In winter we use sweaters, etc. Right? In summer we use clothes which are airy. So these are the developments which have taken place in textiles. Okay. Health, of course, I talked about shelter, soap, bleaching powder, transistor, petroleum products, transportation. In earlier days, if one has to travel from Mumbai to New York, by a ship, it used to take months together. Now from Mumbai to New York, you can make it in 8 hours. Okay, thanks to the developments in fuel technology. Okay, so this is what the importance of chemistry is. Again, I can give a separate talk on how chemistry is useful in our day-to-day life or in modern technology. But when we talk about all these space mission, etc., there are so many chemicals or products of chemistry which are used in all those space missions. Okay, so I hope you are convinced that chemistry is everywhere and chemicals are a very useful class of materials. Okay, chemicals bring benefit to society. Again, talking about agriculture, I think we should know these statistics. In earlier days, like I told you, we were like hunter-gatherer society, correct? So everybody had to go to the farm and earn the food. And today, how many people work in the farm? In America, in the United States, which is a developed nation, 3% of the population work on the farm. They produce food grade, which is not only sufficient for their countrymen, but they export it. How was this possible? Again, through chemicals, pesticides, fertilizers, etc. So you see the importance of chemistry, in agricultural revolution also what we talk about. So these are the of course I already told you the central role of chemistry in modern society. Synthesis of penicillin, urea, polymers, contraceptive pills and liquid crystal display devices which bring clarity to your mobile phones or televisions. Okay? I think at the bottom you must read it. More than 95% of all manufactured goods rely on chemistry. Chemistry underpins industries that have multi-billion-dollar turnovers. Okay. In fact, the turnover of some of the chemical industry is higher than the Indian economy. Okay. So this is what these industries that have been registered for production and use. And those of you who are interested in research or in the creative aspects of science, let me tell you that how many chemicals are possible, which contain carbon or drug-like molecules. The number is 10 raised to 60. Okay. It is theoretically possible that we can make 10 raised to 60 molecules. So we have just only seen the tip of the iceberg. Okay, so people think the chemistry is a matured science, but it is not. There is still a lot of scope. That's why I say, young students, generation, they should be excited about it. Okay, you have an opportunity to contribute to this number. Okay, so one can theoretically make 10 raised to 60 drug-like molecules. I'm not even counting other molecules, inorganic materials, etc. So this is what the scope for research is. And who knows, one of those materials will turn out to be blockbuster drug. It will entirely change the human civilization. So this is what the potential possibilities are. Like if you pursue research as a career in chemistry. Of course, you may argue, some of you may argue, like I told you, chemistry, not all is well. Okay? Only in the movies everything is well, okay? But in real life, not all is well. So if Mother Nature produces so many chemicals, and we were happy in our earlier days also, except that, people, the average lifespan was less, with 40, 50 years. Otherwise, people were happy, satisfied. Of course, happiness is a state of mind. I will not get into all those discussions, but we all are living definitely more comfortable life than what our grandparents enjoyed. Okay. Then somebody may argue, why not depend only on the natural materials? Okay. Mother Nature has made all those chemicals for us. So is there really a need to go for synthetic chemicals? But let me tell you that for today's modern society, we definitely need synthetic materials or man-made materials. Okay. The example in again, they say need is the mother of invention. So these materials, like polymers, were developed to conserve Mother Nature. Like especially these kind of ornaments, buttons, etc., ornaments, chain, etc. Earlier days were made from the trunk of the elephant. Okay. Now imagine for today's population, world population, how many elephants we have to kill. And in the first place, are you supposed to kill elephants, right? We are not supposed to kill elephants, right? We are not supposed to cut trees. So you cannot depend indefinitely on all of these natural materials. We definitely need synthetic materials. Okay? Understand the point, So if somebody says stop doing chemistry, let's go back to Mother Nature and use only what is available in the Mother Nature, but that's not possible because you will not have those kind of comforts what we are enjoying today. Again, just to tell you, I told you about like the amount of money which is involved in this industry. You can see here, the chemical and petrochemical sector, 1,388 million tons of fossil fuel. So when we talk about chemical industry, it's basically petroleum industry. When we talk about organic chemicals, it's basically a petrochemical industry. And there are only 7 basic building blocks. And those are listed here, like syngas, ethylene, propylene, butane, ethylene, butadiene, BTF, etc. It's a mixture of benzene, toluene, xylene. From that, all of these chemicals can be made. That's why we need to have sound knowledge of chemistry, organic chemistry, physical organic chemistry, bond forming, bond breaking, kind of reactions, which is conceptual understanding, like what Professor Sadhir Patel mentioned, LUMO, HUMO. Then only you can decide the structure and properties. So all of these chemicals, agrochemicals, herbicides, pharmaceuticals, pesticides are made from basically from these 7 basic building blocks by carrying out organic transformation reactions. That's why students should know the relevance of what they are studying in the college. when we talk about functional transformation, these are the bases actually by which you can actually design molecules and convert one substance into another substance. You can see the magnitude of this industry, like 557 million tons of secondary reactants, 274 million tons of water per year. This is what the magnitude of this industry is. But then the problem is at the bottom, you can see here, only 31% of the raw materials are transformed into useful products. As you know, except for some rearrangement reactions, the reactions are not atom efficient. So if you on a piece of paper you can write A goes to B or A plus B goes to C, but the life is not that simple. There will be always some kind of unwanted product or byproducts which are formed. Okay? And like I mentioned, when the intended use of the product is over or the material was, it becomes a waste. Then only about 9% of what was produced was recovered in 2019. And again, please remember that today's chemical industry is based on petrochemicals, fossil resources like natural gas, oil, and petroleum. Okay, but these sources chemicals, they have created the problem of pollution, and also where do the chemicals will come from. And that's why scientists and technologists are addressing these issues. And I will share with you some of those approaches which scientists are taking to address those issues of resource scarcity and also waste generation. To address those issues of resource scarcity and also waste generation. Okay, and that's what all these years. I hope teachers are here. We are taught students to make the bonds. Okay, all our textbooks we teach them only to make the bonds. Okay, now time has come. We have to also teach them how to break the bonds. How to break the bonds. Like we know how to make polymers, how to create bonds. But once the polymer is created, it is persistent. It remains in the environment, and that's what is causing problem. So now, how do we deconstruct these polymers? That is something which we need to develop those kind of chemistries or those kind of technologies or pesticides. All these chemicals persist in the environment. Or how do we develop chemicals which are safe? Of course, there is nothing like a safe chemical. In fact, if you take even water is in excess, it causes problem. Sugar, if you take in excess, it causes diabetes, right? So there is nothing like a completely safe chemical. Okay. But I will tell you about that, what the principles of green chemistry or safer chemical are. But this is what I think should be included in the syllabus. Like, how do we break the bonds? How do we deconstruct the polymer molecules? Okay. Of course, the problem, of course, I already mentioned. For the want of time, I will not again. How much time do I have? 10-15 minutes. See, whatever we do lead to pollution. Okay, we inhale oxygen, right? Name it carbon dioxide. But in nature, there are plants around us, right? And what these plants do is they batteries Hello. So again, I'll just do fast forward. Okay. Please remember that there is only planet Earth where the life can exist. Okay. Though we have conquered Moon, but I don't think we can inhabit on Moon. Okay. As of today. So it becomes our responsibility also to protect our planet. Okay. But there is no planet B. There is only planet A, meaning the Earth, where we can survive. So I think it becomes our responsibility, or we owe this to our next generation, that we protect this planet Earth. Okay. Hello?
Yeah.
Can you hear me at the back? Hello? So what is the problem with, chemical industry? The problem is, in earlier days, and down the river, that was the norm, right? We never cared about the environment. Of course, this is like a multi-dimensional problem. Not that chemists didn't know it, but as you know, industry is a profit-making organization. Any industry wants to make a profits. So they did not care so much about the pollution. Okay? But now this is not acceptable. As you know, the rules and regulations are very strict. You cannot emit, anything in the environment, or you cannot discard the waste into water bodies, like rivers or oceans. Okay? Now, of course, this is something big problem. Now, of course, there are also environmental disasters. In fact, chemistry earned a bad image or bad name because of the accident. I don't know how many of you know about the major accident. It happened in the Indian carbide plant in 1984 at Bhopal. The people are still suffering. Okay, there are several such accidents, and one has to accept that accidents will happen, whatever precaution you take. Okay, airplane crash, right? So accidents are bound to happen. Okay, so some risk we have to take. If you decide not to take any risk, the progress will come to halt. Okay, but then we have to find the right solution to this. Don't manufacture chemicals which are harmful to the environment or harmful to the human beings. Of course, these are some of the challenges like greenhouse effect. Why the weather pattern is changing? I don't know, in this winter, Delhi many flights don't take off. You know that, no? Because of the poor visibility. Why it is so? Because of the smoke. No, smoke. I mean, all this. But this was something, a shameful moment for India. The Sri Lankan cricketers, they refused to play cricket match because the visibility was so poor. Okay. Taj Mahal is blackened because of the pollution, right? So this is what actually the problems with chemicals are. When you drive vehicles, you emit carbon monoxide, carbon dioxide. So the level of all these greenhouse gases, methane, it has caused ozone depletion. I will not get into all of that. But this has changed the weather pattern, and actually we have degraded the environment. Okay. So this is what the negative side of chemistry is. Okay. Now, so this is something it has to do with our human behavior. Okay. So the society has moved away from reuse and repair and transition to disposability being the norm. So we are like a throwaway society. All of us drink water from this water bottle, right? But what do we do after this? We discard it. This is a valuable resource. Many times we don't think about it. Like, requires a lot of chemicals to make this, water bottle. So polyethylene terephthalate, again source is fossil resources. Okay, and how many bottles we throw? In fact, you can see these kind of dirty pictures, I call them. Okay? Our oceans are full of plastic. Okay? In fact, the Pacific Ocean is called as plastic ocean because there is so much of plastic which has been dumped. The soil health has degraded, the air quality has degraded. Okay, so these are the problems which have been created by the misuse or human behavior. Okay, so we don't attach importance to these chemicals, and I can go on giving so many such examples. In fact, what is alarming is by 2050 the weight of plastic in the ocean will be more than the weight of fish. By 2050, the weight of plastic. Because in today's world, like I told you, plastic is considered as the top 5 invention. And the world today produces 400 million metric tons of plastic. 400 million tons of which only 9% is recycled. And rest of it goes into water bodies. Okay? So those who are meat lovers or fish lovers, I don't know what you'll be eating. Okay, whether you'll be eating plastic or whether you'll be eating fish. Okay, so these are the kind of problems. Okay, in fact, chemicals have entered into mother's milk, cow's milk. Okay, but they are persistent, they get recycled. This is what is causing problem. Okay, the incidence of cancer has increased. So though humans live longer, life expectancy has increased, but there is a suffering associated with it. Okay. So chemistry has done both good and also bad, in the sense, not chemicals have done bad, but the misuse of chemicals, this is what has created problems. Okay. When we talk about this revolution in communication, mobile phone, you can see here, how much of waste is generated, electronic waste. Again, I will not get into all of this. This climate change, okay? I think this is the generation, meaning all of you young students in this audience here, they have the responsibility. Because we are the last generation that can change the course of climate change, and we are the first generation that then has to live with the consequences. So if you don't change the course of action, if you don't change the path, then the consequences the generation will have to face. Okay? So this is more than a wake-up call for all of us. Okay? So how we produce chemicals, how we make use of them. So basically, what the challenges are, like I told you, we definitely need synthetic materials, right? Because without synthetic materials, you won't see the progress, or you won't be able to enjoy the benefits. Now the question is, these are the two problems, excessive dependence on finite natural resources, like fossil resources, etc. And then they persist in the environment. Okay, so the question is, this is a million-dollar question. Can the materials needs of man be based on the concept of sustainability of both resources and environment? Okay, so how do we produce those chemicals in a sustainable manner so that our future will be sustainable? Okay, and as you can see here, when we talk about moving away from petroleum resources to EV, electrical vehicles, etc. Look at this availability of those elements which are used in electrical vehicles, hardly 1.3%. Okay. The most abundant is, of course, iron and oxygen. This is 90% by weight of Earth's elements are comprised of iron, oxygen, silicon, and magnesium. But the elements which we need, precious elements, that's why they are called as rare earth elements or precious elements. Their availability is only 1.3%. So if you move from petroleum sources to lithium battery or fuel cell, again the problem is of the resources. Okay, so these are very, very complex problem, and we need to address those kind of issues. Okay, again this cycling we already mentioned about it, but you can see 1 ton of mobile phones would deliver 300 times more gold than a ton of gold ore, and 6.5 more silver than a ton of silver. So that much waste we are generating, because we change our mobile after 2-3 years, right? We discard it. It becomes an electronic waste. And I told you its only availability is 1.3% by weight of So these are the kind of challenges which civilization will have to face. And this is something I think all students should be aware of. We teach them periodic table, right? There is something called as periodic table of endangered elements. Like we talk about endangered animals, endangered species, right? So these are the endangered elements, okay? Those shown in the color. So these are available only for a limited period of time. The rate at which we are making use of this. This is, I will need some time to explain this concept of Earth Overshoot Day. Meaning the resources which are available to us. In 1970, we used to consume, whatever resources are available in 1 year. Now, in 2021, we can see by July, August only, we consume all those resources. So at this rate, we will need 1.7 Earths. Okay. By the way, I don't know how many of you know again, though so many developments have taken place, we don't produce food in the laboratory. Food is not produced in the laboratory, by the way, which is the essential need, basic need. Food is only processed in the laboratory. And we have to be grateful to Mother Earth, okay, planet Earth. The plants produce all those food for us, for animals. We eat non-vegetarians, right? And there are no planet B, that's what I told you. And if we follow USA, in fact the rate at which they are consuming the materials, we need 5 Earths. Okay? And all these society, China, India, most populated nations, if they follow those lifestyles, imagine what would be the requirement in terms of the resources. Okay? So these are the questions, So actually human civilization is in danger that way, I don't want to scare you, but this is what the reality of the situation is. Okay? If you continue in the business as usual way, okay, without giving any consideration to this, and this is the responsibility of all of us, like scientists, teachers, to convey to the students what is the problems which they are going to face and what are the problems which they need to solve. Okay? I will not talk about this. So the chemical pollution challenge, this is what the complexity and magnitude of the problem is. I hope you are all convinced, we need to do something urgently about it. Okay? There is no more discussion, no more debate on this. This is a stark reality. Okay? So it's more than a wake-up call. So if you continue in the business as usual, because what we have been doing all these days, and we'll stop here, take, make, use and dispose. This is called as linear economy. Just take from our sources, make something, use and dispose, which becomes a waste. Right? So rather we have to embrace to circular economy, which our great-grandparents used to do. Right? They never used to discard anything, clothes, pots, etc. So one has to have a combination of both these modern lifestyles and the earlier values. Okay, that is what is required. So science alone or technology alone cannot solve the problems of the world. Okay, that's why we need also social responsibility. Okay, responsibility to our next generations. Okay, that's why I said we need a multidisciplinary approach or interdisciplinary approach to solve all these kind of problems. Okay? So this is what humanity's top 10 challenges are. I will stop here by posing the problems. So this is not like an Amol Palekar movie where he will pose the problem and ask audience to find the answers. Okay? But I will tell you these are the problems, and scientists are definitely working. Like Satish Patil is working on energy. How we harvest solar energy, okay? Or wind energy, ocean energy, or geothermal energy, rather than depending only on the petrochemical sources. Water. As you know, in Latur, I know you all have experienced 2-3 years before, right? There are oceans around us, but this is not potable water, drinkable water, okay? So we need to develop technologies for water purification or rainwater harvesting. Then about food, I told you, for the growing population. In fact, you can see the world, 6.3 billion people lived on this earth in 2003. The world is more or less stabilized now. 7.7 billion in 2020. By 2050, there will be 9.7 billion people on this earth. All of them have to be clothed. All of them have to be provided shelter. All of them have to be provided with food. Correct? And the land is limited, right? The resources are limited. So definitely, we live again in energy-driven world. So where the energy will come from? When we will not have these fossil resources. Okay? Where the food will come from? So there are new ways of agriculture farming, right? In agriculture without soil. Those are the kind of technologies which are, being developed. And of course, the other problem is, mitigation rate from countryside to the cities has increased from 30% in 1950 to 55%. Okay? And we cannot stop people. They can be aspirant. They want to have better quality of life. Okay? But then this puts tremendous pressure on the resources. That's why there is a concept of smart cities, okay, where you don't generate the waste or you recycle the waste. So, friends, I just want to tell you that chemistry is definitely an important branch. It is needed to bring the comforts to our lives. But there are at the same time chemistry, the way it was practiced earlier, has created problems. So we have to have a new ways of practicing chemistry or new ways of producing chemicals, and what those new technologies are. Maybe if Professor Palkesar invites me again, I will share with the students what scientists are trying to do so that we make the protect our environment and derive all the benefits from chemicals. Okay. There are actually courses taught now. Sustainable chemistry, not only chemistry but sustainable chemistry. What are those sustainable practices? Those have to be imbibed in the students at this stage itself, so that they become better citizens, they become aware of what the problems are, and they can think of approaches to solve all these mega trends or mega problems. Okay. So friends, thank you very much for listening to me patiently. And I hope I was able to bring some excitement, like what chemistry can do, but at the same time make you aware of what the problems are. That's why you all are needed. New chemistry is needed, young generation is needed to solve all those problems. Thank you very much.
Any questions from the audience? Any questions? Any question? Thank you very much, sir, for your very insightful speech. Question is there. सर एक जनरल क्वेश्चन होता मराठीत विचारतो मुद्दा म्हणून सगळ्यांना व्यवस्थित समजेल. तर सर तुम्ही जे म्हणलात की 3% अमेरिकन हे ॲग्रिकल्चर मध्ये इन्व्हॉल्व आहेत आणि भारतीय, मला असं वाटतं की नियर अबाउट 80% इन्व्हॉल्व. हे कदाचित कारण नसेल का की आपल्यामधून सायंटिस्ट कमी तयार होत असतील, कारण ज्याला त्याला वाटेल मातीत जन्मलेला होता आपण, तर आपण शेतीच करावं, आपण शेतीकडेच ओढा असेल. आणि दुसरा क्वेश्चन की सर भारतासारख्या कृषीप्रधान देशामध्ये माती भरपूर असताना विदाउट सॉइल ॲग्रिकल्चर इज इट पॉसिबल और इज इट बेनिफिशियल ऑर नॉट?
त्याच्यावर खूप मोठं डिस्कशन लागेल आपल्याला. माझा सांगण्याचा उद्देश काय होता अमेरिकेत की टेक्नॉलॉजी एवढी ॲडव्हान्स झालेली आहे की एवढ्या लोकांची गरज नाही असं म्हणण्याचा उद्देश होता. शेती करून ह्याच म्हणण्याचा उद्देश नव्हता. बरोबर आहे. नाही आता भारतात सुद्धा जर तुम्हाला चॉईस दिला, लोक ॲग्रिकल्चर का करतात तर त्यांना दुसरं काम मिळत नाही. मला वाटतं बरेच लोक आवडीने करतात, पण बेसिकली हा म्हटलं होता फक्त टेक्नॉलॉजी एवढी ॲडव्हान्स झालेली आहे यू डोंट नीड एवढं मोठं काम आवश्यक.
टेक्नॉलॉजीवरती होतं, इकॉनॉमी तिथली टेक्नॉलॉजीवरती होतं. एवढी टेक्नॉलॉजी आपल्या इथं नाही आहे, त्यामुळे
वी आर गेटिंग देअर ना. एवढं नाही करू नये. मला सांगायचा उद्देश काय आहे की टेक्नॉलॉजीनं काय चेंज घडवून आणलं असं म्हणण्याचा उद्देश होता.
आपल्याकडे आता ॲग्रिकल्चरमध्ये टेक्नॉलॉजीचं
प्रोडक्टिव्हिटी वाढवू देत ना, चांगलं झालं.
आणि गरज आहे आता सध्या.
विदाउट सॉईल, तुम्हाला माहिती आहे सॉईलमध्ये सॉईलची क्वालिटी किती खराब झाली आहे. दुसरा प्रॉब्लेम होता सॉईलच्या मध्ये
सुदेवा सर.
Thank you very much, sir, for having a very insightful speech. Rightly, we have said that we are our life is made by technology. Life is made easier by technology, but we are facing now a technology-driven problem, and definitely our students and aspirants will definitely try to solve the technology-driven problem. Thank you very much, sir. And thank you for allowing us to reschedule your keynote. Thank you very much.
Please submit your registration and feedback form before leaving ELC hall. A break refresh the mind for greater thinking. Thank you all for your enthusiastic participation. At this point, we will be taking lunch break. Lunch will be served at canteen. Lunch coupons are available in your kit. We kindly request all the dignitaries and participants to please proceed to the lunch venue and enjoy your meal. The next session will be resumed at 3 p.m. We request everyone to be seated in the hall 5 minutes prior to schedule.